Good afternoon. I'm Eri Moon at Deokseong Women's University. I'm the Vice President for External Relations of KAST. I'll be the moderator of this opening session. It is my great pleasure to welcome you to the International Symposium co-hosted by the Korean Academy of Science and Technology, KAST, and the National Academy of Medicine of Korea, NAMOK. I thank all the speakers and online audiences and distinguished guests who spared valuable time for this meaningful event. Today's symposium is about climate change, environment, and health. I hope you have a great time learning and sharing on how the environment affects human health and how we can prevent a variety of environmental health issues. Yeah. And now, I would like to introduce Professor Yuk-Jun Woo, the president of the KAST. President Yu, please.
Thank you very much. Distinguished guests from home and abroad, ladies and gentlemen, it is my great pleasure to welcome all of you joining us both on and offline to the 52nd Joint International Symposium co-hosted by Korean Academy of Science and Technology and the National Academy of Medicine of Korea. My special gratitude goes to Professor Dong-Chun Shin, the chair of the organizing committee, and Professor Kyu-Chang Wang, the president of the NAMOK, for their efforts to organize this timely symposium. Also, I would like to express my warm welcome and sincere gratitude to the outstanding speakers. Today, we hold this symposium on climate change, environment, and health. Most of us have heard of climate change for quite some time. This issue has developed into the question of how much it will affect our life. More and more people are being concerned with this unwelcoming change. So now is the best time for scientists to think seriously about this matter, to find out what is lying ahead of us, and to reach out to our solution. In this regard, we entitled the theme of this symposium, Climate Change, Environment, and Health. I hope today's symposium expands our knowledge and gives us insights into how climate change affects the ecosystem and our health. Finally, once again, I would like to extend my utmost gratitude to all our distinguished speakers for their great contribution to this symposium. I hope that we will enjoy this successful event in the viewpoint of knowledge exchange and mutual collaboration. I also hope this symposium will be remembered as an unforgettable moment to all the participants on and offline. Let me now close by wishing you all a delightful and fruitful symposium. Thank you very much.
Thank you very much for the warm welcome address. And now I would like to introduce Professor Kyu-Chang Wang, the president of NAMOK. President Wang, please.
Thank you, Professor Moon. It is my great privilege to invite all of you to this International Joint Symposium hosted by National Academy of Medicine of Korea, NAMOK, and the Korean Academy of Science and Technology, KAST. The NAMOK holds international symposia to gain insight into global health issues from internationally reputable leaders and experts. This year, the theme of the joint symposium is climate change, environment, and health. This theme is very timely as we face more rapidly changing environments than ever, including climate change, natural disaster, air pollution, and the drastic increase in chemical use because of COVID-19. There is an urgent call for sharing more in-depth knowledge about how the environment affects human health and for discussing how we can prevent a variety of environmental health issues. In this on and offline hybrid event, we have 9 distinguished speakers from the United States, Switzerland, Japan, China, Spain, as well as Korea. I believe that this event will be a great opportunity to connect internationally reputable researchers in the field of climate change, air pollution, chemicals, and health. I would like to express my sincere gratitude to all speakers, chairpersons, and those who participate in this symposium. Thank you for your attention.
Thank you very much for your very thoughtful remarks. Before we begin the first session, we will have a short photo time. We will have a 3-minute break. Today's symposium is composed of 2 sessions. The first session is about climate change and health, and the second session will be on environment and health. The first session will be chaired by Professor Yoon-Chul Hong at Seoul National University. Professor Hong, please.
Thank you very much for introduction of me. I will chair the first session, which is titled Climate Change and Health. As spoken, we all understand that climate change and health is one of the really important issues we humanity face. So it is urgently required to address this issue properly and also to prepare what we are going to do to combat climate change risk. So in this the session, we will have 4 speakers to address these issues. Probably each speaker will have 25 minutes, so I hope each speaker keep the time. And I would like to introduce the first speaker, Christy Abbey. Dr. Christy Abbey is president, professor in the Center for Health and the Global Environment. Dr. Abbey's scientific training includes 2 years of postgraduate research at the London School of Hygiene and Tropical Medicine. She has been conducting research and implementation on the health risk of climate variability and change for 25 years. She has supported multiple countries in Central America, Europe, Africa, and Asia and the Pacific in assessing their vulnerabilities and implementing adaptation policies and programs. Particularly, she is a leading member of Climate Change Environment Technical Advisory Group of WHO WEPRO, which I chaired. Welcome, Chris. Now we will have her recorded presentation. Please.
Hello, I'm Christy Ebi. I'm a professor in the Center for Health and the Global Environment at the University of Washington. I really appreciate the opportunity to talk with you today, and am sorry that I can't be in person, but I hope perhaps next time. I want to start with the figure on the left. That is how the international community frames risks from a changing climate. This is not specific to health, this is for all sectors. When we think about the future, there's lots of uncertainties. And so we look at risk, where risk is probability times consequence. In climate change, risk is composed of 3 major factors. The first are the hazards that are created by a changing climate. The second are the human and the natural systems exposed to those hazards. And the third is the underlying vulnerabilities and capacities. There's lots of understanding on the health side of vulnerabilities to temperature, precipitation change, as well as the capacities of our health systems to manage. The figure on the right is one of many figures that summarizes the health risks of a changing climate. Across the top are some of the changes that are occurring from burning of fossil fuels and emitting short-lived climate pollutants that are causing rising temperatures, sea level rise, and increases in the frequency and intensity of extreme weather events. These then interact with a broad range of demographic, socioeconomic, environmental, and other factors that influence the magnitude and the pattern of risks. Together, these affect exposure pathways. The exposure pathways are the kinds that have been studied in environmental health for decades. On the left, extreme weather and climate events, across to the right on social factors. Underneath are a short list of examples of climate-sensitive health outcomes. There are hundreds of climate-sensitive health outcomes, so this is just a snapshot of the breadth of concerns with a changing climate. I'll speak about some of these. I don't have time to speak about all of them. They all are important. This is a summary of the Intergovernmental Panel on Climate Change report published this year, the chapter on human health. As you can see, this is on observed impacts, where the headline statement is climate change is adversely affecting the physical health of people globally and the mental health of people in regions where there were data. The major categories that were assessed include extreme weather events, waterborne disease, zoonotic disease, water and foodborne diseases, mental health, cardiovascular and respiratory distress. I won't talk very much, but the last bullet point is also very important. Too many of our healthcare facilities are in areas that can be disrupted by extreme events such as flooding. This affects not only the functioning of those facilities, but also significantly impacts health workers. The workers that are in those facilities that can't get home to take care of their homes, their family, their friends, and makes it difficult then for people to access services when they need. And this will, at some point, be a whole separate talk. I wanted to highlight mental health. It's an issue that's becoming of increasing importance on the climate change and health agenda. These are data following a massive flooding in the southeast of England, where the researchers looked at people who were unaffected by the flood, people who lived in a residence where the floodwaters essentially came to the front door but didn't come in. Their lives and their livelihoods were disrupted, but they weren't actually flooded themselves. The third category are people who lived in a residence that was flooded. The researchers assessed the prevalence of probable depression, anxiety, and post-traumatic stress disorder. As you look across these three mental health challenges, you can see the significant increase in the prevalence of these mental health challenges from the flooding event in both the disrupted and in the flooded. And you can see much higher prevalence, of course, in the flooded. You also can see that the prevalence declined over the 3 years of follow-up, but not that much, that there is still a very high level of mental health outcomes following this massive flooding event. There are very few places in the world that are prepared for the mental health services that are needed during and following major extreme weather and climate events. Much of the research on climate change and health is focused on heat. Global average temperatures are increasing. At the same time, there's an increase in the frequency, intensity, and duration of heat waves. The physiological pathways for heat to affect our bodies are well known. Of concern is the core body temperature. We have physiological mechanisms and behavioral mechanisms to try and cool down when we become too hot. Behaviorally, people will go and find a tree to sit under, they'll find some place to sit in the shade, they'll turn on an electric fan, they'll find a way to try and cool down. Physiologically, there's a range of mechanisms, including, for example, sweating. When together those mechanisms are insufficient to the rise in core body temperature, that increased temperature starts affecting our cells and our organs. After a heat wave, when there are analyses of excess deaths, about half of those excess deaths are from cardiovascular causes. These are, for example, people who die from a heart attack, who would not have had a heart attack otherwise. This is why we say that almost every heat-related death is preventable. Nobody needs to die in a heat wave. I mentioned there's been an increase in the frequency intensity of heat waves. These are data from the Lancet Countdown showing exposure of adults over the age of 65, children under the age of 1, to higher temperatures. You can see the numbers on top in 2020, that older adults were affected by 3.1 billion more person days of heat wave exposure than the long-term average. You can just look at the trends across the graphs. Significant increase in exposure. Worldwide, there's been increasing numbers of extreme heat waves beyond what has been experienced before. I'll use the example of what happened here in Seattle last year. There was a heat dome that settled over the region for several days. the temperatures were beyond what's ever been experienced. Apologies that the numbers are in degrees Fahrenheit. That's what we still use here in the US. But overall, across the region, the previous temperature records were broken by about 5 degrees C. Typically, temperature records are broken by tenths of degrees, so this has been basically unheard of. Very high temperatures, the numbers are still being analyzed, but over this entire region, over 800 excess deaths occurred. And it wasn't just the deaths, which of course are devastating for the families and friends. Also, there was impacts on worker productivity. There were impacts on crops. Heat is an all of society issue. It was the height of our cherry picking season, lost much of the cherry crop. Our wheat crop was affected. Also, between Seattle and Vancouver, there are lots of oyster, mussel, and clam beds. During low tide, the temperatures were so high that about 1 million mussels, clams, and oysters were literally cooked. This affects food security for coastal tribes. There's many other examples of these extreme heat waves. We are seeing them more frequently with climate change and can expect to see more of them into the future. There's a field within climate science called detection and attribution. This is a sophisticated statistical analysis that does what the name implies. It detects whether there's been a change in a long-term trend, and then determines the extent to which climate change caused some portion of that change. Detection and attribution is being applied for health. This is a recent publication for 43 countries, more than 700 locations, looking over the last several decades and matching the analysis with a multi-model comparison program on detection and attribution. Overall, the result of this analysis suggests that about 37% of all heat-related mortality over the last couple of decades can be attributed to climate change. These are people who are dying from climate change. You can see high variability across the countries, with some regions more vulnerable than others. You can see there's just one country in Africa, South Africa. A lot more work needs to be done in this space, but overall, we are now starting to count the number of people dying of climate change. I live in the Pacific Northwest, so when I think about heat, I think about wildfires. These also are data from the Lancet Countdown, showing an increase in the number of days people were exposed to very high or extremely high fire danger in 2017 to 2020 compared with the long-term average. Much greater exposure, particularly a problem here in the Northwest and across the whole West Coast of the United States. This matters because wildfire smoke is associated with increases in the prevalence of diabetes, lung, and heart disease. In the United States, we have something called the Air Quality Index that looks at the number of particles in the air of a particular size. These particular size particles are kind that when you inhale them, they go deep into your lung, essentially stick to your lung tissue, and are absorbed into the body, which is why you see these associations with increased risk. An air quality index over 60 is unhealthy for anyone to breathe. Last year, my neighborhood, for 2 solid weeks, had an air quality index of over 250. The sky was yellow, dawn to dusk, no sun, no clouds, nothing, just solid yellow. Last summer, there were wildfires outside of Los Angeles. There were communities in Los Angeles with air quality indices of over 750. This increase in wildfire smoke means very heavy exposures, the consequences of which are being studied because there's new research coming out indicating that wildfire smoke is more toxic than the equivalent amount of particulate matter from, for example, tailpipes. And of course, these are not independent. This is research from British Columbia looking at where in British Columbia there are communities that are more at risk. The authors developed a set of indicators to look at exposure to extreme heat, the sensitivity of the population, for example, the proportion of older adults, and the capacity of those populations to manage extreme heat waves. They did this not just for heat, but also flooding and sea level rise, ground level ozone. Ozone's formed on clear, cloudless days. The rate at which it's formed is temperature dependent, and wildfire smoke. And then they put this complex vulnerability mapping together to show the places in British Columbia where it's urgent and immediate that action be taken to start addressing the health risks of a changing climate. I expect that there's going to be more vulnerability mapping like this coming out over the next couple of years, because it's so very helpful for decision makers to know where they need to start focusing today. The IPCC chapter also looked at the projected risks. The short list of projected risks is smaller than the observed impacts, and that's in large part because of the very limited funding in this area. There hasn't been an opportunity for researchers to conduct the kind of research that they would like to do to better understand how climate change will affect the future burden of climate-sensitive health outcomes. But you can see some of the significant findings from this overall assessment on extreme events, food, water, and vector-borne diseases, and mental health. When we think about the future, we know it's going to be hotter. This is a sophisticated study that was conducted for the United States that points out some important considerations for how we plan for a different future. These are annual heat-related deaths. The top row is where the model assumed there would be adaptation to higher temperatures. The bottom row, no adaptation to higher temperatures. The left column is business as usual. We keep burning coal, oil, and gas at about the same rate we're doing today. The middle column is where there are modest reductions in our greenhouse gas emissions. And the far right is where there's real aggressive action to reduce emissions. This is a world aiming to achieve the Sustainable Development Goals. And you can clearly see the pattern. You can compare in the bottom left, business as usual, no adaptation, with the top right, where there's aggressive emission reductions and adaptation, and see the very different possibilities for the end of the century. It really is urgent that action be taken, and we need to take it now. The other important point about these sets of figures is if you look at the figure on the top right, that even with aggressive adaptation and mitigation, there will continue to be what we call residual risks. Overall, taking adaptation and mitigation into account, there'll be more people at risk from high temperatures. Heat-related mortality will continue to rise unless we ramp up our efforts even higher. Likely the biggest impact of a changing climate is going to be food insecurity. And that goes through two pathways. The first is shown on this slide from the IPCC. You can see that the columns are maize, rice, soybean, and wheat. I'm not going to look at soybeans because they're really very different. The top row is the yield change at mid-century, the bottom row yield change at the end of the century. The colors and the bars have to do with extent of greenhouse gas emissions, from low in the dark blue to high in the red. But you can just look at the pattern across these major cereal crops and see large reductions in crop yields projected, even mid-century. Right now in the world, there's about 820 million people who are food insecure. all the projections suggest that with additional climate change, that number will continue to rise. The other mechanism is through carbon dioxide itself. All of our plants have a photosynthetic pathway by which they bring in carbon dioxide from the atmosphere, break it apart into carbon and oxygen, and use the carbon to grow. Sometimes you'll see people writing that carbon dioxide is plant food. And indeed, it is plant food, that plants need the carbon dioxide to grow. 85% of our plants use one particular photosynthetic pathway. The biochemical characteristics of that pathway mean that it's called a C3 plant. And you can see in this figure that CO2 promotes plant growth, which means there's more carbon in the plant, which means you have more carbon-based molecules. That translates into more carbohydrates in plants. At the same time, with greater carbon in the plant, there's less nitrogen in the plant. And that results in fewer nitrogen-based compounds. So you see about a 10% reduction in protein and about a 30% reduction in B vitamins. Also, C3 plants under higher concentrations of carbon dioxide are more water efficient. So they bring in less water from the soil, which sounds like it should be a good thing given increasing drought in so many regions. However, it also means that these plants bring in fewer micronutrients. The major micronutrients that have been studied are iron and zinc. I mentioned about 820 million people in the world are food insecure. About 2 billion have micronutrient deficiencies. About 1.5 billion women and girls have iron deficiency anemia. The projections for how higher concentrations of carbon dioxide could affect the nutritional quality of our food and what that means for human beings ends up suggesting that this pathway could affect hundreds of millions of people by the end of the century. There are iconic figures used by the IPCC to synthesize risks. These are the figures for 4 climate-sensitive health outcomes: heat, ozone, malaria, dengue, and other diseases carried by Aedes mosquitoes. When you look at the figures, the 0 line are pre-industrial temperatures. The y-axis are temperatures above pre-industrial. The color scheme is where the bar is white. It means that scientifically it's not been possible to determine if there's been a change, for example, in heat-related mortality. When the color turns to yellow, it means, in fact, that there has been a shift in heat-related mortality, and at least with medium confidence, some of that shift is due to climate change. When the color turns to red, it means the risk is high. When it turns to purple, it means the risk is very high. As you can see, for each climate-sensitive health outcome, there's 3 adaptation scenarios. The one on the left is a world with high challenges to adaptation and mitigation. The one in the middle is a world that continues to muddle through, doing something well, something's not quite so well. And the one on the right is a world with proactive adaptation, where the world really tries to achieve the Sustainable Development Goals. The middle and the right bars are truncated at the temperature projected in 2100. Looking across this, you can immediately see the urgent need for adaptation and for mitigation. We need to do both to protect human health and well-being. There are lots of very effective adaptation options. This is a list of the major categories that were assessed in the IPCC chapter. All of the climate-sensitive health outcomes are of current concern. That means there's policies and programs in place for all of them somewhere. However, none of them were developed taking climate change into account. There needs to be a lot of effort to improve these policies and programs to explicitly incorporate climate change. One of the key adaptation options is to develop a national adaptation plan for health. Every other year, the World Health Organization surveys countries about what they're doing with respect to climate change and health. You can see that in 2021, only 91 countries responded, and of those, only half have a national health and climate change strategy or plan in place. And a much smaller proportion reported they had high or very high levels of implementation. This is because the lack of investment in this area. When you look at the funding under the United Nations Framework Convention on Climate Change for adaptation, less than 0.5% has gone to health. There are so many possible ways to improve our resilience to a changing climate. Here's some examples for heat. The left is a poster that's typical. It's from Quebec. It shows the kinds of actions individuals can take to protect themselves. The middle top shows heat action plans, which are critically important for increasing the resilience of communities, for planning what to do when there is the next heat wave. And the bottom is a headline from several years ago about the inequities of heat. The poor and the marginalized live in places that are hotter and therefore have higher exposures when temperatures rise, and illustrates how important it is as adaptation options are implemented that they always be viewed through a lens of equity. Mitigation, critically important to bring down our greenhouse gas emissions, but also to be aware that when one looks at these mitigation options, they all have benefits for health. And those benefits for health accrue before the benefits for the planet. There are a growing number of studies estimating the avoided hospitalizations, the avoided premature deaths from mitigation actions. The overall conclusions are, when you take into account the benefits for health, then the value of these benefits is greater to or equal to the cost of mitigation. We should be mitigating for our health. This slide shows one of many examples this one's from New Zealand, where just shifting 5% of short urban car trips to bicycles could save $200 million in health costs. Lots more can be done in the space, and we need to get the message out that when we talk about mitigation, we should talk about the health benefits. The research agenda on climate change and health is long. There's a lot of research that needs to be done. I really appreciate you listening about a little bit of what we know about how climate change is affecting our health, and think about the ways that you could incorporate these challenges into your own research so that we really broaden our understanding of the breadth and depth of the challenges and the opportunities to intervene so we increase resilience. And finally, when we think about the health impacts of a changing climate, about 85% of those are in children. So think about the ways that we can do more to help protect the children today and of the future from our changing climate. Thank you very much for listening, and I hope you have a very fruitful conference. Thank you.
Thank you, Chris Ebai. With her very kind presentation with a clear message, we now understand that climate change is impending and its effects and the impacts are increasing now. But she also stressed the importance of proactive management of climate change. She will give us a better future. Thank you again, but she's not online, so we will need to go to second speaker. I'd like to introduce second speaker briefly. Professor Ho Kim, currently professor and former dean of Graduate School of Public Health, Seoul National University. He has been conducting research on the impact of air pollution and climate change on human health for more than 25 years, with a special focus on the long-term health effects of environment, air pollution, and methodology development, especially for the East Asian countries. He is a former president of Korean Society for Health Informatics and Statistics, and is the current vice president of the Korean Statistical Society and of Korean Society of Climate Change. Would you please give us your presentation?
Thank you, Professor Hong. It is my great honor and pleasure to have a chance to present today. The first speaker described the overall perspectives of climate change and health successfully, and then in her talk, she stressed the importance of projection already, I think. And my motivation is that why we care about climate change. There would be hundreds of reasons, but as a public health researcher, climate change is killing people. That is one of my answers. And how about a future generation? It is 100% sure that climate change will kill more people in the future. So how much? So I'd like to, I wanted to answer that question. So that is the topic of today's presentation. So let me start with, to have a better projection, the evaluating current situation is very important. This is one of the most cited and comprehensive papers so far, reporting the burden of temperature-related deaths. And their conclusion was that totally 7.71% of the mortality was attributable to non-optical temperature. And I will explain this term soon. And the other conclusion was that of the 7.71%, the burden due to cold was 7.29, but by heat, it was only 0.42%. So most of the burden is due to cold right now. But the meaning of these numbers are a little bit difficult, I think. And this is the summary table in Korea. They reported MMT, minimum mortality percentile, which is the percentile of the ambient temperature with minimum mortality. This is far from 50%. So this is also very important, and this number is a little bit larger than other countries in South Korea. And in South Korea, the totally 7.24% is the fraction due to non-optimal temperature. And cold and heat is like about 7 point and about 0.31%, not the fraction. This is percent, so actually it is 0.0031 in this case. So the relationship between temperature and mortality is generally U-shaped, and this point, this temperature is called MMT, with minimum mortality over here. It goes up in the hot temperature or cold temperature. So, and they reported this is 89% of the whole, this is the distribution of daily temperature. So totally, about 90% of the days are below this MMT. So when we calculate the burden for days with temperature less than MMT, it is about more than 300 days in a year. So the reason why we get big number in the cold is mainly because we have so many days over here. So that is one of the problem, I guess. And extreme heat, and extreme cold was defined by the days with below 2.5 percentiles of the temperature and higher than 97.5 percentiles. So it's like 9 days and 9 days for a year, respectively. So that is the basic idea in calculating the burden, current burden. So that we have so many days over here, so that the fraction is largest in the moderate cold area. And all other countries shows very similar patterns. And how about the dose response between temperature and mortality is always U-shaped, but in some countries it is very steep over here, so that the heat effect is very large over there, as well as cold temperature over here. So in Korea, you can see that we have steep increase in the heat area, but less steeper in the cold area over here. So this is the similar picture I've shown, but most countries have a relationship. I mean, the patterns are very similar, I think. And so there are some issues, especially related to projection. Definition of cold and hot days, they used 25% MMT and 97.5%. But the problem is the MMT is not near median, 50%. So the number of cold and hot days are very different. So that burden is proportional to the percentage of days. So in this here, this is extreme cold and moderate cold and moderate heat and extreme heat. So in our practice, we just delete the moderate region over there. So we use 2.5% upper and lower. Baseline period is from year 2000 to 2020 to define extreme cold and extreme hot, cold spell and heat wave, and try to estimate burden for the extreme events only, not in these moderate regions. But the problem is that this 2.5 percentile are quite different from location to location. So it shows the distribution. So we see that this is the more colder area, as you can see, and this is warmer area in the winter, and similar pattern in summer. But you can clearly see that in the metropolitan cities, the 97.5 percentiles are higher over here. So you can clearly see the so-called heat island effect in the urban area in Korea. And the mean value among the Sigungu county level is like 27 and -5 in the cold region. And the other important issue is how to define risk. So this is general shape of temperature and mortality, and this is MMT. In the previous Lancet paper, they calculated risk of this temperature compared to MMT. So this is the risk by their definition. But we defined 2.5 percentile over here and there. So our risk is from here to there, which is way smaller than their calculation. So we actually try to estimate burden of hot temperature compared to this temperature, not over here. So our actual number would be much smaller compared to the previous calculation, I guess. For example, in here, if I calculate the risk of this temperature, I call risk MMT based is by this blue arrow. But if I calculate a risk based on 97.5, then this arrow is a new risk by this definition. Similarly, we have similar pattern for the cold over here also. And by this paper is only reporting evaluation current situation. 2 years later, this group, which we call multi-country, multi-city study group, we call MCC group, led by Dr. Antonio Gasparini, who is a professor at the London School of Hygiene and Tropical Medicine. And I'm also a member of this collaboration. And they reported the time trend of the health burden by years, by scenario, which is also very important. I will explain a little bit later. So they used 3 scenarios, but in one scenario, there are several meteorological models developed by, say, US or UK or Australia or Japan. That is called General Circulation Model, GCM. So they use 3 RCPs and 4 GCMs, and then they reported ensemble average of 4 GCMs. And those are the scenarios of RCP. So the previous speaker said it's like minimum emission and moderate emission or business as usual. You can interpret it that way. And this is cold effect, which is decreasing, expected to be decreasing because temperature is rising. And this is an effect of heat, which will increase rapidly in certain area. But it depends on the location and depends on the scenario. And this is projected year. So as you can see, I think in this area, in this comparison, this area, Southeast Asia and South America and the Central America, those are 3 most vulnerable regions, I think, Southern Europe also. And then you can compare between the scenarios. And so there are so many contrasts if you whatever you are interested in. So we did a similar approach and it shows the increasing risk of heat and decreasing risk of cold. So let me explain the scenarios. So that the IPCC's recommendation is golden rule in this area. So it started with SRES, so-called, and RCP. RCP is still widely used. And then SSP is most current recommendation, considering socio-economic pathways. So the current methodology is combination of SSP and RCP, as I will explain later. And SSP is kind of combination of mitigation and adaptation. So SSP1 means very good mitigation and good adaptation. So this is the best scenario, and this is worst. We have 5 combinations. This also is very complicated issue, so I don't have enough time. But so that SSP2 is kind of average, and 1 is the best scenario, and 3 is the worst. So our future temperature, as well as carbon, the CO2 emission, will be depending on our choice of our society. So if we do our best, I mean, in reducing CO2, then that is SSP1, RCP 2.6. So we call it SSP1 to 6, SSP2 for 5, and up to SSP5 8.5. So this is the worst case without any policies, and we, if we do our best, then this is the projection. Yeah, and then so I'll show you the result of our study so far. And in Korean study, projection of population, I found it very difficult, very difficult. And I think it has a huge uncertainty over there. But three scenario, SSP 1, 2, three scenarios over there. Over here is the projection of population. Sorry for the small picture, but 200 and 2100 over here. So our population is decreasing and rapidly decrease after 2050. But based on the scenarios, the pattern is almost same, but the numbers are slightly different. And number of deaths is also increasing due to the progress of aging society, I think. And but interestingly, after 2080, the increasing pattern is much slower, even decrease, because the population size itself is so small, so that we expect fewer deaths. But the number of mortality due to heat is heavily depending on the number of deaths per day. So this scenario is very important source of uncertainty, I guess. And the number of hot days and cold days, you can imagine number of cold days is increasing rapidly, and number of cold days will decrease based on the scenarios. And the other important issue here is that we estimated dose response curve by 250 counties, 시군구s over there. This is statistically very challenging problem, because each county has very few population size. So getting this stable relationship is very challenging, but I don't want to spend time on this. So we estimated different county-specific dose response curve between temperature and mortality over here. So this is the result. These are the current excessive mortality, national sum, total. So, and those are the projected values depending on the scenario. So, but I think this number itself is not very important, but the ratio is much more important. So in year 2040, we expect at least 3 times burden compared to current, 5 times and 6 times, depending on the scenario. But the difference will be much larger in 210. It's like about 8 times and 30 times and 60 times. So our paths, the difference is getting larger and larger in the future, depending on the current policy. That is the most important message over here, I guess. And that is the actual number itself. But if we calculate fraction, mortality fraction, which is the proportion of the heat and heat mortality divided by total mortality, currently it's like a heat wave, it's like 8%, less than 8%, but it's going to be much larger. This is a percent, not the actual number. So again, if we look at the ratio fraction itself is going to be about 25% in year 2010 under the worst scenario. Okay, and death count and the When we calculate death count, because of the speedy change of population number, we try to estimate deaths per 100,000 over here. Still see the patterns are very similar over there. But the difference between the scenario is getting larger and larger. But here, the difference between best and intermediate scenario is not that different, but worst scenario, the best scenario gives much better output. And this is by county, by scenarios. So expected mortality itself is proportional to the population size. So we expect most of the deaths occur in the metropolitan area like this in both scenarios. But if we present relative mortality by 100,000, you see that in this area, there is much higher mortality because of the two reasons. Because of the population composition of elderly and number of heat days. As you remember, the heat days is more, we expect more heat days over here. So in this south west area, they have two risks same time, high temperature and more elderly population. And this paper is about nighttime heat. So we call it tropical light, 열대야 in Korea. And here we did similar simulations depending on two scenarios. In this case, we didn't do for the worst scenario, but still the number of hot days, hot nights will be very different. But similarly, we call near future and far future. Then the difference in near future is not that big. But we see more and more difference in the far future here in this research again. So this is a similar pattern for any projection, I think. And it shows the differences between, I call GCM, the meteorological models. So frankly, there are very heterogeneous results based on the GCMs. So that uncertainty is a very important issue methodologically in the projection study. So I think I have to be very frank that the previous speaker showed some result of projection, but you need to understand huge uncertainty on that figures, I think. So this is the last slide. Why we want to do a projection study? The purpose of projection is not to predict accurately the future, but rather to organize the choices we currently have and to compare the result of those choices to help us make the choices in front of us. So we all demonstrated that the current choice has a huge impact on the future of next generation. So we need to make a good choice, but this kind of projection study will provide scientific reasons of our choices. But there are many methodological problems such as uncertainty. And some research topic linked with individual or societal lifestyle and specific policy are very important. So as I showed, we only used SSP, and that is kind of a very general scenario. But if we have more specific scenarios, then the result will be more practical and interesting, I think. So considering the policies and the consequences in the future, if we do this way, then we stay in this area. But if we don't do anything over there, then our future will be, will be very harmful. So the choice is in front of us, I guess. Thank you.
Thank you very much, Professor Ho Kim. If you have any comments and questions to the speaker, would you please raise your hand? Otherwise, I will give you the question. Actually, you should show the different scenarios and the different health, the outcomes, and particularly the impact, the number of deaths. And the first speaker, Christy Abbey, also stressed the importance of proactive management and aggressive the policy to reduce carbon dioxide. We all agree that with if we do really efforts to reduce emission, we will have better health outcomes. But different scenarios require different socioeconomic cost and different the health benefit. So because we need to live our lives to be sustainable, so we need to have a choice what would be the best scenario, the balancing health economic cost and also health socioeconomic cost and health benefit. So what do you think is the best scenario considering socioeconomic cost and health benefit?
I think the question is not only applicable to climate change, but applicable to all problems in health and environment, I think. We know that air pollution is bad, but we cannot stop running our car. So finding the balance is very difficult and very political and economical problem, I guess. So we all agree that climate change is harmful for current generation and the future generation. But if we provide how much, then it helps policymakers to make some plans and in near term and long term, more reasonable way. So, but I think the changing, and it also helps general population to persuade them and to change our policy and behavior, pushing politicians to change our laws, for example. So the current situation is like that. So we have a huge, the conflict between and groups, I guess, and it also the problem of values, which is more important, the current generation or future generation, environment or developing. So everything is not so well, organized today. So addressing this issue to the general public is our responsibility, I think. So
thank you very much. I agree that everything is about the value we have. Yes. So I would like to invite the next speaker, Professor Yoon-Seok Chang. I will give the brief introduction. Professor Zhang is currently a chair professor at UNIST and an emeritus professor at PostSec. His research field of interest is environmental analysis and monitoring and the human health effects, mostly for POPs, persistent, the organic pollutants. So would you please give us your presentation?
Can I unmute mask?
Sure.
It's very hard to breathe. So, okay, first of all, I thank the organizing committee for invitation. Yeah, even though I am a faculty in UNIS now, but this work has been done by my former student at Posttech. Okay, I think my last presentation in English was before the pandemic, so maybe 3 or 4 years ago. So the English today is very inconvenient and uncomfortable for me. Likewise, the global warming is also very inconvenient, uncomfortable for some people, especially this guy. But this is almost a fact because the modeling for the temperature increase with all kind of factors such as the natural factors, orbital changes and solar and volcanic, and human factors, land use and ozone, aerosols and greenhouse gases, we are matching to the observed the data. So for certain period of time, global warming is a fact. So have you watched the Netflix movie Don't Look Up? So if you watch the movie, then the science is conflicting with politics and business, but unfortunately, the victims are us, ordinary people. So that's why the global warming is uncomfortable issue for politicians and some business people. So here, as Professor Kim showed us, if we don't take any action, then the temperature will increase to 4.5 Celsius degree in 2100. And if we take some action according to the Paris Climate Agreement, then it will be 3.5. And we follow well the Paris negotiation, then we can keep the temperature increase by 2 Celsius degree. So different from the global warming, climate change is, I think, just a popular theory because there are also some minor groups who are against the fact of the climate changes. So we have to collect more evidences to confirm the climate change. So such as the occurrence of the tsunami and tornado, deglaciation, and drought, and etc. So the current environmental issues related to the climate change include the carbon neutral renewable energies, such as the solar, wind, and tide energy, and water shortage, especially in the third world, and clean air with the problem of the fine dust, and environmental health of the human animal ecology, and waste management, and the new emerging chemicals and the microplastics. So today I focus on this this topic, the emerging chemicals and micro products, micro and nanoplastics, based on the increase of the temperature. Environmental variables such as the temperature, wind speed, and precipitation, and solar radiation have influences on the fate of chemicals. Among them, the temperature is the key meteorological parameter, and the climate change can influence every step along the fate and transport and distribution pathways of chemicals in the environment. And a multimedia model also shows the influence of climate change on the atmospheric concentration of chemicals. such as that the increase in the atmospheric concentration in the inland areas is largely attributable to the decrease in atmospheric deposition, and decrease in the atmospheric deposition is caused by the change in the temporal pattern of precipitation, and decrease in the sea areas is due to reduction of wind that carries chemicals from the inland areas to the sea. So this figure shows the emission of chemicals into the environment, air, soil, and water in Korea. So just for the last 2 decades, there are 4 times increase of the chemical emission into the environment. So that means these days the humans are largely exposed to environmental chemicals as well as other synthetic chemicals such as personal cares and the pharmaceuticals. And the increase of the temperature also affects the revolatilization of chemicals in the Arctic. The chemicals that have accumulated in the cryosphere are released during ice snow melt, and those stored in seawater are volatilized back into the atmosphere, resulting in the increase of concentration of chemicals in the environment. And it also affects the enhancement of the degradation of chemicals. So some chemicals are degraded into more toxic byproducts. So according to the result of multi-component chemistry transport models, the degradation rate of POPs in the environment are estimated to increase by a factor of 2 or 3 for every 10 degrees Celsius degree increment. And the different from the conventional chemicals, the micro nanoplastics are very important issue these days. This is very ubiquitous. It's present all over the world. So there are 2 types of the microplastics. One is the primary microplastic that is commercial product, and also degraded plastics in the environment. And also most the microplastics contain harmful chemicals. So by increase of temperature in the environment, the release of chemicals from the microplastics will increase also and exposed to humans. And maybe you heard about One Health, which is the combination of human health and animal health and the environment. So these 3 are interdependent, and at the same time, these 2 depend on the environment. So by the definition of WHO, it is an integrated, unifying approach to balance and optimize the health of people, animals, and the environment. And it is particularly important to prevent, predict, and detect and respond to global health threats such as the COVID-19 pandemic. And it involves the public health, veterinary, and environmental sectors, and its approach is particularly relevant for food, water safety, nutrition, and control of zoonosis, and pollution management, and combating antimicrobial resistance. So these kind of things are all very well related to the climate change. And this figure shows the history of virus pandemic, and some of them are the zoonosis pandemic, as you see. Interestingly, I remember that the first the COVID was in China in January, early January 2020. And the first patient in Korea was on the January 20th of the 2020. So you can see by the satellite observation, you can see the difference between the pandemic and just after the pandemic. So this picture was taken just before the January 20th of the year 2020. And right after that, also the Korea was also quarantined, and the NO2 level was very much lowered. And interestingly, just before the pandemic, COVID-19, we had occurrence of the African swine fever, ASF, in late 2019. So, and early 2020. So this is not the human pandemic, but the pandemic for the swine and pigs. So very similarly, we have actually the government has taken all kinds of actions, including the installation of defending fence, is still undergoing. So like pandemic, we expect that the pandemic, the COVID-19 might be ended as some kind of in 2021 or something like that, but as like the COVID-19, this ASV is still going on. And I talk about among the many chemicals, I focus on the POPs today. And these POPs, persistent organic pollutants, are characterized by the high toxicity and persistency and bioaccumulation and the long-range transport. Oops. And there are some classes of the POPs molecules, and one is the initial 12 POPs that include some OCPs, organic the chemicals, and hexachlorobenzene and DDT, Milex, and PCB and dioxins. And new POPs include the new OCPs, organochlorine pesticide, and brominate flame retardant, and also the perfluoroalkyl substances, so-called PFAS. And the one important characteristic of the POPs and the human exposure is we are exposed to these molecules every day and at very low levels, not very high levels. So this figure shows the relative concentrations of the POPs in human serum. So in 1 cc of human serum, there is approximately 2 milligrams of lipid, but most POPs are present in nanogram level, and for especially PFAS, the perfluoroalkyl substance is a microgram level. For dioxins, it's very, very small, so a picogram level, so it's PPT level, 10 to minus 12 gram. So unless you have very high resolution analytical technique, then you cannot detect. These figures show the annual trend in serum in Korean for general Korean people. The different trends among POPs are mainly due to the use and the regulation of each compound. So by the regulation, governmental regulations, the dioxins and OCPs are slowly decreasing, even in human serum. But the commercial products, PFAS, and new pesticide DP are increasing. And the POPs are the form of the environmental hormone. Most POPs are a form of the environmental hormone that disrupt the function of the natural hormone in our body. So it affects the metabolic syndrome, heart disease, and diabetes, insulin resistance, hypertension, etc. And the toxicity of PAPs are expressed by TEQ values, which is the multiplication of the toxic effect equivalent factor and its concentration. And we have some report, mostly reported done by Professor Lee Duk-ki here. She's here today, and we have some good evidences of the effects of the PAPs molecules on some environmental disease, including the diabetes and obesity and others. And other important fact, the characteristics of the PAPs is the biomagnification of in food chain. As the most problematic compounds biomagnify in food chains, sampling of top predators yield a global picture of ocean pollution. And there are some different type pathways for the human exposure to PAP, but in general, almost 90% is through the ingestion by food. So even though this is general routes for human exposure to chemicals, ingestion, inhalation, and absorption, dermal contact, the ingestion is the most important pathway for human exposure to PAPs, most PAPs. So we have conducted for 3 classes of the PAPs for the general, the time trend and health effect. And first class is as I mentioned before, the popular alkyl substances. And these PFAS are synthetic chemicals with oil and water repellency and resistance properties. Therefore, we consider to be exposed by low concentration PFAS chronically. And among the many PFAS compounds, this PFOS and the PFOA are most important pollutant affecting the human health, and this hexa compound, including this hexa compound. Even these compounds are detected in tap water, not only in Korea but in many other countries. So when you drink tap water, even the the bottled water, there are chances to have the PFAS compound. And this is the human exposure pathway of PFAS to a human and toxicological effect. Due to the time limit, I just skip the detailed result, and you can refer to the Symposium book. Okay, so we have done the many in detail studies, and I just skip that, and I just move on to the summary. Let's see the second from the second one. In the study of 10-year temporal trend, the PFAS level showed an increasing trend until early 2010, and then decreased, which reflected the international and domestic regulatory trends of PFAS. And the PFAS level was significantly higher in males than in females, and showed significantly positive correlations with age. So with higher older age, the higher concentration of the PFAS. However, the BMI didn't correlate with the PFAS levels. For clinical factors, PFOS was positively associated with the TC, glyceride, and the LDL, and PFOA with glyceride, and PFNA with TC. total cholesterol. And uric acid and FT4 also showed positive correlations with major congeners with while concentration between thyroid stimulating hormone and PFAS were inconsistent. And there was significant difference in this PFXX congener and this congener levels between participant with and without diabetes. And principal component analysis suggests possible difference in disease manifestation and based on the congener distribution of PFAS. And this is a summary of the first study. And then you can see more data and discussion in this paper. And next class of the POPs is for organochlorine pesticides, OCP. And OCP has been used for many years for human, and actually that solved the problem of the food problems for especially for third world. And this is the history of human exposure to OCPs, and also this kind of chemicals are mentioned by in this book, famous book Silent Spring, written by the Rachel Carson. And there are two types of OCPs. One is old OCPs and the new OCPs. So the thing is that the chemicals are banned by government or by some organizations, and new chemicals are designed and really and used, manufactured and used, and then those chemicals again are banned by the same groups. So it's kind of the circulation. So anyway, so these new OCPs are also banned, and maybe chemists are also now designing the new OCPs to avoid the regulation. And especially for OCPs, the insecticides are frequently found in eggs, especially in Belgium and other European countries, as well as in Korea. So I also skipped the detailed result and then move to the summary. The OCP levels showed significantly positive correlation with age and BMI. However, there was not significant difference between the levels in males and females, different from the PFAS. In this study, a 12-year temporal trend reflects the international and domestic regulatory trends of OCPs. And most of the correlation between the cholesterol and OCP levels followed a non-linear pattern, U-shaped association with the regression line showing a positive slope at low exposure levels that decreased, even became a negative at higher exposure levels. And it was associated with reduced F4 levels and increased the TSH levels. And uric acid also showed positive correlation with major congeners. There were significant difference in major OCP congener levels between participants with and without diabetes. And this principal analysis suggests the possible difference in decreased manifestation and based on the congener distribution of OCP. Because time is almost running out, right? So I also skip the third class of PAUs, dioxins, so that you can see the text, the program book. And I'll move on to the very last page. So I hope the Professor Lidocki will talk about the PAUs and health more in detail and more nicely. But for myself, as a non-medical person, I believe that blood and lymph circulation is very important for my health. If blood and lymphatic circulation is good, then amount of chemicals in human body reaching the liver and kidney will increase, promoting the release of chemicals from the body. So besides several kinds of the exercise, this kind of activities are my very routine for keeping my health good. So the low intense stimulation of body may be very helpful for good circulation of the blood and lymphatic the system. So this is called it can be explained by the hormesis. So perhaps Lee will talk about the hormesis in the second session, right? Okay, thanks for your.
Thank you very much, Professor Zhang. I think the 25 minutes is not enough for you to cover your topics. So now it's open to floor for questions and comments on this. Otherwise, the time is running, so we will go to the next speaker. Thank you again. The next speaker, Alexander Puzrin. So this is the last speaker, but not the least speaker of the session. I will give a very brief introduction of Alexander Puzrin. He's a professor and chair of geotechnical engineering at the East Zurich, Switzerland. He studies natural and man-made hazards such as landslide, earthquake, tsunami, snow avalanche, and dam failures. His other interests are in application of novel sensor technology to geotechnical monitoring and in assessment and mitigation of geotechnical eco hazards. I think he will give us a very interesting speech. Professor Puzrin, would you please give us a presentation?
Good afternoon, ladies and gentlemen. Thank you for inviting me to talk today. I'm going to explain why doctors should be worried about climate change in the mountains. I know that you have mountains in Korea. I also know that you have doctors. Hi, Dr. Yang. But my personal relationship with medicine is rather complicated. Both my father and my grandfather were surgeons, but I rebelled and became an engineer, and as you are going to see, I'm still struggling with this decision. Main effects of the global warming in the mountains are greater temperature swings, less snow during winter, more rain during winter, and more intense rain and snow storms. These changes have implications for geohazards affecting human health and safety. Some of these implications are rather counterintuitive, and we will talk today about 4 such paradoxes. It appears that less snow can cause more snow avalanches. Less snow can result in heavy avalanche injuries. Snow can cause mudslides instead of avalanches. And doctors are those that should be particularly worried about these changes. Paradox number 1. Less snow can cause more snow avalanches for 2 reasons. Reason 1, greater temperature swings create weaker layers within the snowpack. Second reason, more intense rain and snow storms serve as additional triggers. And indeed, the biggest avalanche cycles on record in Switzerland happened just in the last few years, coinciding with some of the warmest years ever. Second paradox is less snow can result in heavier avalanche injuries. This story started in the end of 2019 when my colleague John Gom and I decided to shed some light into an old mystery. The Dyatlov Pass incident took place in the Russian Ural Mountains in 1959 and costed 9 young hikers their lives. It inspired numerous conspiracy theories, but we demonstrated that a small snow avalanche was a plausible explanation. To do that, we used computer simulations, data from the impact tests on cadavers performed by General Motors in Detroit in 1970s, and old autopsy reports from the Russian criminal investigation in 1959. We managed to demonstrate that this avalanche could cause severe but not life-threatening injuries, breaking between 6 and 12 ribs, consistent with the autopsy results. These injuries complicated the hiker's escape, leading to their death from hypothermia. Pretending to be a medical expert has changed my life dramatically. I landed the role of a James Bond villain on Swiss TV, became a superhero in a Latin American comic strip, and had the National Geographic, the New York Times, and the New Yorker reporting on my work. But what was really interesting in this study is that these heavy injuries were not typical for regular avalanche victims. You get so many broken ribs only if the avalanche hits you against rigid ground, as was the case with the Russian hikers. This was confirmed by numerical analysis and by GM tests with restrained back. We see that less snow can indeed result in heavier avalanche injuries for two reasons. The first one, less snow implies a smaller avalanche, but also a thinner snow cushion on the ground. And second, even a small avalanche can cause heavy injuries if it hits you against a rigid obstacle. Which brings us to the third paradox, how snow can cause mudslides instead of avalanches. This story happened in the end of 2020 after I got a phone call from Pierre Clavien, who asked for my help. Pierre is a world-famous Swiss surgeon and a friend of Professor Han Kwang Yang. He has a beautiful chalet in Swiss Alps. But on the 2nd of February 2020, it did not look so beautiful anymore. After a strong rain, which was preceded by several days of snowing, The slope above Pierre's chalet collapsed, liquefied, and caused a mudslide damaging his property. Luckily, Pierre and his family were not there, but a neighbor was woken up by the terrible noise. She saw how mud and water rushed huge stones and fallen trees downslope. She called Pierre, police, and firefighters. But as Pierre was telling me this story, something didn't sound right. Such relatively small slopes are supported by vegetation and do not liquefy so easily when they fail. A colleague sent me recently a photo of a similar failure taken 4 kilometers away from Pierre's house 1 year after his mudslide. The soil just remained on the road in a rather neat pile. So why such a difference in less than 4 kilometer distance? Pierre had an explanation. It turned out that 100 meters uphill from his chalet, there is a historic 500-year-old irrigation channel, Bisvia. It is a tourist attraction. People hike along it. But unfortunately, it is not maintained everywhere as nicely as it is shown in this tourist booklet. This is how it looks like just above Pierre's chalet. You can see the water stalls here due to the erosion of the channel banks. In the summer, the channel gets water from the local river, but in the winter, the gate is closed and the channel is supposed to be empty. But it was not empty on the night of the 2nd of February. Pierre's neighbor walked her dog along the channel and discovered that it was almost overflowing. If she went a bit further, she would see that the flow was blocked by snow right above Pierre's property. This blockage was discovered and removed by firefighters after the mudslide event. Next morning, the neighbor went up again and found the location where the water had overflown the channel banks. Pierre claimed that it was the overflow that caused the mudslide. But the municipality and their insurance were not convinced. They claimed that the slope collapsed due to the strong rain. They did not want to pay for damages. And this is why Pierre needed my help. And I thought, you see, Grandpa, a surgeon needs my help. So, how could we prove that Pierre was right? First of all, we had to demonstrate that the slope has survived even stronger rains in the past. Looking at the historic precipitation data, we found out that rain events of similar magnitude happen on average every 2 years. The road was built 60 years ago, therefore the slope survived around 30 such rains. Furthermore, in its lifetime, it survived at least one rain which was twice as strong as the one on the 2nd of February. And in any case, even if you have enough water to collapse the slope, you will need much more water to liquefy it. It became clear that the only source of this additional water could be the overflow from the channel. But this was not enough. We had to understand the mechanism of this failure. The problem is that soil is not very permeable and was protected by vegetation. Therefore, there was not enough time for the water to penetrate the slope, and the water would just run off the slope surface. It seemed that the only plausible mechanism was that water attacked the slope, not from above, but from below. It first filled the crack in the underlying rock. Then water pressure caused local piping, erosion, and collapse. Finally, failed soil mixed with water and caused the mudslide. For doctors, if you want to understand piping, think about a fistula. Under pressure, the water finds a preferential flow path, eroding material on its way. And in the beginning, it looks rather innocent. But if you see something like this, just run away. Because this erosion will involve more and more material and bring the dam to collapse. These two videos were recorded during a collapse of a huge tailings dam in Israel, which I recently investigated for the Israeli Ministry of Environment. It created a toxic wave which traveled 20 kilometers through a nature reserve to the Dead Sea, killing everything on its way. 3 years after the disaster, the ecosystem has not yet recovered. The estimated damage is around $250 million. But let us go back to Pierre. How to prove it was piping? First, we need to make sure that the water pressure in the cracks was sufficiently high to cause the piping. And then to show that water could get into the rock, say via a rock outcrop with open cracks. To find the pressure, we use piping criteria which we developed for the Israeli case. We had to modify them a bit to account for vegetation, but do not worry, I know how doctors love formulas. My father, when he found out that I am good at mathematics, wanted to have a paternity test. It appeared that you only need 3 to 4 meters of water in the cracks above the road, which is easy to accumulate during an overflow. And what about rock outcrops with open cracks? To find them, we organized an expedition. And we found them. Right on the way, the water was flowing from the channel to the chalet. This is how such a rock outcrop looks. And this is an open crack. But ironically, towards the end of our expedition, we discovered that someone has left an abandoned well open, which would bring the water into the rock without a need for any rock outcrops and cracks. So the case was solved, insurance paid, Pierre repaired the damage, but I had to spoil his joy, because this story can now repeat itself every winter. Because the reason it has not happened before is that you first need lots of snow to block the channel, and then lots of rain to overflow it and cause the mudslide. In the past, it was a rare combination. but due to global warming, not anymore. The good news is that you can mitigate the damage. First of all, by proper maintenance, and Pierre convinced the municipality to repair the channel. And second, by proper monitoring. I was thinking about some high-tech solutions, such as drones flying around, but Pierre told me that he has solved the problem. His poor neighbor was so scared by the mudslide that she now patrols along the channel every day with her dog. And last winter, she already prevented the next disaster by reporting the blocked channel to the firefighters. So we explained the first three paradoxes. But what has it all to do with the doctors? First of all, doctors should be concerned about heavier injuries from more frequent snow avalanches, which means they will have a lot of work. Injuries from mudslides are even more severe because mud is 3 times heavier than snow. Second, I discovered that doctors love skiing. There is even such a thing as the European ski meeting in facial plastic surgery in Switzerland. And recently, British media reported that thousands of doctors are missing from hospitals and GP surgeries during the winter crisis because they are on jollies to medical conferences at 5-star ski resorts. Finally, I do not know how it is in Korea, but in Switzerland, you cannot be considered a proper doctor if you do not have a chalet in the mountains. But exactly this can make you an early victim of the climate change. The good news is that now, if you are worried about your chalet, you know whom to call, right? To conclude, I would especially like to thank Dr. Yang for inviting me to this conference. He and I met at a conference in Zurich last June, which was organized by our joint friend, Dr. Pierre Clavier. And Dr. Yang did 2 great favors for me. First, he took this photo of my son, and second, he explained to me that if my son becomes a doctor, this will correct my mistake and bring the surgeon dynasty back on the right track. Thank you, Dr. Yang. And thank you all for your kind attention.
Thank you, Professor Bujurin, for very interesting speech. Now it's time to open to floors about the question and comments on his speech. I think Professor Yang needs to respond to his call. That is not working.
Dr. Bujurin, thank you very much. This is Dr. Yang, and I'm embarrassed by you showed a couple of pictures. Yes. By the way, your lectures are so, how to say, you emphasize this global warming is really right in front of our yard, in front of us. So again, I'm not good at this environment, but you enough warned us about the impending impact by this global warming. Thank you very much.
Thank you, Dr. Yang. It was really a pleasure to present here. Thank you very much for this invitation. And indeed, you know, we think that we are prepared. But the reality says that there are a lot of surprises. So we should be prepared for surprises, not for what we think is going to happen.
Okay, Professor Pujurin, thank you again for your very nice and interesting presentation. And now I'd like to close the session with four very good presentations from four speakers. We will have a nice session about climate change and health. Thank you very much for attending this session, everybody.
Thank you.
Thank you, Professor Hong, for chairing the first session. Now we are going to have a coffee break for 10 minutes. Thank you. Now we begin the second session of the symposium. The topic of the symposium is environment and health. Professor Dongchon Shin at Yonsei University will chair the second session. Professor Shin, please.
Thank you. Good afternoon. And thank you for joining in this session, in person here and also YouTube as well. We have 5 presentations in this session. 3 presentations will be virtual from Japan, Spain, and China. First presentation is by Professor Toru Takebayashi in Keio University, Japan. He's a professor at the Department of Preventive Medicine, School of Medicine, Keio University. And his current research interest is application of integrative epidemiology for risk assessment. He received the MD and PhD from Keio University and MPH from Harvard School of Public Health. He's now Vice Dean of School of Medicine, and also he has leading roles in the academic society at the Japan Society for Occupational Health and also Japan Society for Hygiene. Now we invite Professor Toru by screen, and right after the presentation, we'll meet him to discuss. Dr. Toru,
Hi, everyone.
please.
My name is Toru Takebayashi from Keio University, and it's a great honor to be here. Today, I will talk on our experiences to apply molecular techniques into environmental epidemiology. Our goal is to solve emerging and re-emerging environmental health issues by employing the metabolomics and other molecular techniques to define risk assessment methodology. In Healthy Longevity Society, the population studies focus more on changes in functional capacity over the life course, with taking into account the contribution of environmental and social factors. At the same time, the progress in the omics technology, molecular understanding of health and diseases, from genes to the metabolome, as well as recent progress in data and computer sciences, is another important aspect of environmental health research. Especially the metabolome. The metabolomics is not only closest to the disease phenotype, but also the metabolites can also modulate the various biological events. Furthermore, it is possible to understand that the metabolic profile shows a snapshot of the metabolic fingerprint resulting from interactions of gene and environment. Thus, we initiated a population-based cohort study in Japan integrating both. The Tsuruoka, the metabolomics cohort study, TMCS, was initiated in 2012 in Tsuruoka, where located in 200 miles north from Tokyo. The participants were 11,002 resident workers in Tsuruoka and recruited for 3 years at the time of the yearly municipal or worksite health check programs. Age range were between 35 and 74 at baseline, and the participation rate was 89%. We collected the biospecimens, including plasma, serum, urine, and then graphic code, and also the lifestyle and health information through a self-administered questionnaire at baseline. And we were doing the repeated measurement and the surveys at 3 to 5 years. And for the metabolomics, the validity and precision of the measurements is prone to the sampling, measurement, and the storage conditions. So our cohort optimizes sampling, measurement, and QC procedures as the large-scale metabolomics cohort study. The metabolites, the small-sized molecule, have wide variety of the physical and chemical properties. So we employ CEMS, the capillary electrophoresis mass spectrometry, to identify and quantify over 100 the polar and hydrophilic metabolites absolutely, and then LC liquid chromatography MS to identify and quantify over 200 neutral hydrophobic metabolites semi-absolutely. Our cohort is ongoing, and every 3 to 5 years we do the repeated survey and measurement of metabolome. And from 2018, 2 sub-cohorts, aging study and the women's health study, were launched. In this talk, I'll focus on presenting 2 examples of environmental epidemiology. The first one is the study on the HTP, heated tobacco products, and second one is study on environmental cadmium. For the HTP study, we employed DNA methylation, gene expression, and metabolome as an early effect biomarker. HTP, which heats tobacco leaves without burning it. Therefore, it is said that emit less harmful chemicals than the combustible traditional cigarettes. The PMI is the world leading company of HTP. I understand that in Korea, KT&G is also one of the major players of HTP. Use rate among smokers in various world cities in 2019 was shown here. Here's the Tokyo and here's Seoul. And now in Japan, its prevalence among smoking populations exceed 30% recently and still increasing. So I guess the situation in Seoul and Korea is similar. This slide shows the emission of hazardous chemicals in mainstream aerosol of HTP and the conventional cigarettes. And let's place indicates the result of the VOCs, and blue shows the result of the polycyclic aromatic hydrocarbons. And the proportion shown here, almost all hazardous chemicals in HTP were lower compared to the conventional cigarettes. So based on this reduced emission, tobacco industry advertise that HTP are more desirable for the health than conventional cigarettes. But reality, evidence is not to be established if use of HTP can reduce health risks of various chronic disease, including cancer. So we initiated the 3 studies in this issue. We first analyzed the effect on lung function as reduction of forced expiratory volume in 1 second, FEV1. Since IQOS had been introduced into Japanese market in 2014, and it used surged in 2016 among younger generations through the social media and the popular TV program. So we evaluated change in FEV1 between 2012 and 2018 among the 2,612 participants. This table and the figure show the adjusted decline in FEV over 6 years. So cigarette-only group as reference, degree of decline was shown here. And degree of decline was better among the never smokers, the past smokers, and HTP users compared to the cigarette-only smokers. But the most importantly, use of both cigarettes and HTP, so-called dual user, showed further reduction compared to the cigarette-only smokers. That is one issue. From the 2018 survey, the prevalence of HTP differed by age. Among younger group, relatively high, 5% in prevalence compared to the 0.8% among the older population. But the proportion of dual use is compulsory high among the older group. The most important health outcome is lung cancer, COPD, and cardiovascular disease related to tobacco. But it requires long enough observation period in a traditional cohort. Alternatively, we employed markers of molecular events related to these health outcomes. For the lung cancer and COPD, we employed DNA methylation and the gene expression. For the cardiovascular diseases, we employed the metabolome. This type of approach is called as meet-in-the-middle approach in molecular epidemiology. Before our study, cigarette smoking was associated with the hypomethylation of CPD sites of AHRR and F2RL3 across two cohorts, NOAC cohort and MCCS cohort. You see the never smoker here, the degree of the DNA methylation was highest, but then among the current smokers, the degree of the DNA methylation was the lowest. The result was the same across the two cohorts. Furthermore, hypomethylation of these resulted in the future development of COPD and lung cancer. In the first quintile, was the highest in terms of the DNA methylation. As a reference, hazard ratio 1.00. The fifth quintile, the lowest methylation group showed 4.58 of hazard ratio, significantly increased the risk of having the COPD. Also, in terms of lung cancer, the results are the same. The highest group is the lowest risk, and the lowest DNA methylation group showed the highest risk of having the lung cancer. By the mediation analysis as a whole, the hypomethylation of these sites mediate causal link between smoking and lung cancer. It is estimated to be the 31% explained by this methylation, 32% through the F2RL3 methylation, So in study number 2, we picked up 52 HTP users. Actually, they were switched from conventional cigarette smoking from the study participants. And then we selected the equal number of the neighbor smokers, past smokers, and cigarette smokers matched on with the propensity score. Then DNA methylation on selected CPG sites and whole transcriptome sequencing were performed. Of 29 CPGs in 17 genes, 17 CPG sites in 10 genes were significantly hypomethylated in CS and HTP users compared to the neighbor smokers. I'll show one typical result of the change in the DNA methylation. This is an enlarged graph of HRR, and you can see that the degree of the DNA methylation was the highest with less variation among the neighbor smokers, very high. The orange circle showed the result of the conventional cigarette smokers, and the lowest, you can see the DNA hypomethylation among the current smoker group. And green one is the past smokers. Blue one is the HTP. They both are very similar and then located in between the neighbor smokers and current smoker in the middle. For the gene expression analysis, the result was similar. This graph shows the result of the PCA analysis. And the red is the cigarette smoker, and then the blue is the neighbor smoker, the green is the HTP, the orange is the past smoker. So totally different from the cigarette smokers and neighbor smokers, and located in the middle for the HTP and the past smoker. In the third study, we are now working on analyzing data on the metabolome analysis among the study participants. Here we show the result, the comparison between the cigarette smokers and the neighbor smokers. Under the mini plasma metabolites, 48 in males and 28 in the females, and the 22 in common are higher or lower compared to the neighbor smoker among the cigarette smokers. So we picked some of the key metabolites from this analysis, and then we compared the cigarette smokers, HTP users, past smokers, and neighbor smokers. Especially the key metabolites relating to the glutamate and its metabolism, which are related to the regulation of nitric oxide. This time, the changing pattern of the key metabolites among HTP users are relatively similar to the current smokers. Here, glutamate is here. So, interpretation from our 3 studies on HTP and health, HTP users displayed DNA hypomethylation of targeted 17 CPG sites in 10 genes compared to neighbor smokers with similar transcriptome profiles, albeit to lesser extent than the CS, current smokers. HTP users showed higher plasma concentration of the key metabolites, which may mediate a link to the atherosclerosis in cardiovascular diseases, similar to the result of the TCS, the current smokers. Molecular genetics and metabolic effects of long-term HTP use are still unknown. So long-term population studies are needed. And we are now doing the follow-up study of this population. I will show a second study on cadmium quickly. Among Japanese, main route of intake cadmium is food, especially rice and tobacco smoking. As an early effect biomarker of renal toxicity of cadmium, urinary NAG and acetyl beta glucosamidase is widely used. In our study, we explored if urinary metabolites can be a biomarker at low cadmium exposure, where urinary NAG concentration is within the normal range. This slide shows the roughly result of our analysis. And led with low exposure level, where the NAG stayed normal range, urinary concentration of the 45 metabolites in total were increased or decreased in a dose-dependent manner with relation to the cadmium. And then according to the human metabolome database, about 36% of these urinary metabolites and 90% of the plasma metabolites were located in the mitochondria, blue part. And additional pathway network analysis revealed that the cadmium exposure was associated with the TCA cycle-related metabolism, suggesting that the metabolic profiling might detect the effect of cadmium exposure on renal dysfunction at an earlier stage than NAG, because metabolites in mitochondria sensitively reflect change in the upstream regulators of tubular disorders. So interpretation of our study, our metabolomics-based approach have revealed candidate biomarkers for cadmium exposure that reflect the mechanism of the cadmium toxicity. We are also working on the integrative studies of the prevention of non-communicable disease, mainly focusing on cardiovascular and metabolic diseases. We found mediating metabolites of the cardiometabolic lifestyles, including physical inactivity, obesity, diet, and alcohol drinking and smoking. And also, these metabolites are related to the dyslipidemia and metabolic syndrome. These results also might be applicable to environmental epidemiology of chemicals on cardiovascular and metabolic diseases, because these metabolites might be common to the environmental risks as a key mechanistic pathway for this NCD development. So, in conclusion, I'll show the future direction and implications. Integration of metabolomics and other omics with population studies can provide information on important molecular events such as alteration in DNA methylation by epigenomics, and disturbance in metabolic pathway by metabolomics. From the point of view of health risk assessment, the metabolic perturbation by environmental pollutant may be an early sign of adverse metabolic diseases and or cardiovascular diseases, and is potential to be a biomarker in adverse outcome pathways. We will strive for bridging the gap between these molecular events and future adverse health outcome, conventionally used in health risk assessment. These are our research groups and collaborators. Thank you for your attention.
Thank you. Thank you, Toru, for your very nice presentation, introducing us your integrative epidemiology cohort employing metabolomics for risk assessment. And the first topic is HTP, is, although it is not yet familiar with in Korea, but we recognize it's a very big issue in our world. And then you introduced some attenuated toxicity of this product. And so there are less amount of volatile organic compounds and polyaromatic hydrocarbons, but the same level of nicotine. So some effect is almost same. And then you found some attenuated toxicity in hypomethylation or the gene expressions. So it's very interesting. And your cohort, I think, is really huge one, from genome to the population, and employing very highly sophisticated analytical technology. So no one can catch up with your study. So firstly, is there any comments or question from the floor? We have about more than 30 people in our room. Otherwise, I will comment a little bit further. And I have just one question for cadmium study, which is very interesting to all of our environmental specialists. And you mentioned mitochondrial toxicity. Yeah, we know that most of chemicals are behaving in our body as a mitochondrial toxicity, and this topic will be very in-depth dealt with Dr. Lee's presentation. Her presentation is at the last of our conference. So do you comment on the microbial toxin for the cadmium toxicity a little bit more in detail?
Thank you, Professor Sim. And the mitochondrial change in the renal tube is the key for the kidney toxicity from the cadmium. So we are not sure still, because this is just the cross-sectional analysis of the cohort. But still, it is possible to looking at the subclinical very early change related to the cadmium toxicity. So we are now going to follow up these population to looking at the future change of the kidney function, maybe the 5 years or 10 years. And then we can conclude this kind of the slight change in the mitochondrial metabolites. It's the causal, the early sign of the kidney change related to the cadmium exposure. So from the in vitro and then in animal studies, it could be a very high possibility. It could be the key metabolites, but then in human, we need to the follow-up study to confirm this change. That's my comment.
Thank you, Toru. Another my brief comment is for the HTP, what is your basic motivation to select a HTP for the first of your interest in your big cohort study? I think there will be much of mechanistic result is expecting using if we use HTP for a study object. And what's your future plan on this HTP issue?
I already mentioned that the HTP is now the very high pitch, the increase in the prevalence and the users in Japan, and then so it's kind of the emerging the public health issues, but and also in the advertisement, the tobacco, the manufacturers, they insist that this is the safer and healthier compared to the traditional tobacco. but we don't know the exact the evidence. That is my motivation. But then in this cohort, only the switcher from the conventional tobacco can be observed. So the new user must be examined whether the same result will be observed. So in the future, we have to look at the incident user, new user of the HTP, show the same result or not.
Okay. Okay, if there are no more questions, thank you again, Toru, and we hope to see you in Tokyo or Seoul or in other place. Thank you, bye-bye.
Yeah, thank you.
Okay, let's move on to the next second presentation. It's also very interesting topic. Will be by Professor Jerim Cho. Is an assistant professor in the Department of Preventive Medicine at Yonsei University. She is a medical doctor in preventive medicine, specializing in environmental epidemiology. Recently, she studied in UK, King's College of London for a master's degree in psychiatric research and PhD in the University of Auckland in New Zealand, and returned to Korea, Yonsei University last year. She has conducted studies linking air pollution to various health outcomes, including depression, anxiety, allergic disease, inflammatory disease, and cardiovascular disease. She is working on neuroimaging studies on the effect of air pollution on brain structures, and recently published some of the studies in EHP and Stoughton. Please.
Thank you, Professor Shin. I'm honored to make a presentation in this prestigious international symposium. And in this talk, I'd like to introduce some epidemiological studies to better understand the relationship between ambient air pollution and neurodegeneration. There is consensus about the neurotoxicity of particulate matter. Particulate matter affects the brain via two pathways, direct and indirect mechanisms. So the key term is inflammation. So when we breathe the air, particulate matter can go into the lungs, and there local inflammation occurs, and this local inflammation increases the level of cytokines, and circulating cytokines can induce neuroinflammation. In terms of direct mechanism, very small particles can enter the brain. To be more specific, ultrafine particles may physically enter the brain via the olfactory nerve in the nasal cavity. If you look at this figure, there's olfactory bulb and olfactory nerve, which is connected to the brain. And when you look at this box, this is an olfactory bulb neuron. This is nucleus, and there's cytoplasm. You can see some abundant black spots, which are ultrafine particles. So this is very straightforward evidence showing that very small particles can enter the brain. In terms of indirect pathways, as I said, circulating cytokines can induce neuroinflammation, and particulate matter is a mixture of pollutants, including neurotoxic substances, for example, lead, mercury, and manganese. Another explanation is that air pollutants can affect mental health by worsening of physical health and aggravation of chronic diseases. In this talk, I am focusing on neurodegeneration, so Alzheimer's disease is the main target. There is a term called Alzheimer's disease continuum, which means that Alzheimer's disease progresses along a continuum from preclinical stage, which refers to no cognitive decline but have abnormal brain biomarkers, and to MCI, mild cognitive impairment, and then clinically apparent dementia. So all your studies have focused on these clinical stages. So let's have a look at the studies. So this is the first epidemiological study linking air pollution and cognitive decline. They used the NAS2 data from about 1,800 adult participants of the third and Hayes data. They used simple reaction, motor response, attention, and short-term memory as the outcomes. They found that ozone was significantly associated with reduced cognitive performance, but PM10 was not. And this study was published in Archives of Internal Medicine in 2012. This may be the landmark study to raise awareness about air pollution issues among clinical neurologists. So they used the Nurses Health Study Cognitive Cohort, including 200 US women ages 70 to 81 years. And they looked at recent and long-term exposures to coarse particles and fine particles preceding baseline cognitive testing. Global cognition score was calculated from telephone assessments, and they found that both coarse particles and fine particles were associated with significantly faster cognitive decline. Cognitive decline can lead to mild cognitive impairment, MCI, which was the outcome of this study. This was a cross-sectional analysis of the Heinz-Nixdorf recall study in Germany. Out of 4,000 participants aged 50 to 80 years, about 600 participants were diagnosed with MCI based on cognitive assessment. If you look at this figure, long-term residual concentrations of PM2.5 were associated with increased risks of overall MCI and amnestic MCI, but not with non-amnestic MCI. And it is known that amnestic MCI or MCI with memory loss is more closely related to Alzheimer's disease. So the final stage of Alzheimer's continuum is Alzheimer's dementia. This study was published in Lancet Planetary Health in 2020. This was a retrospective cohort study. It was very large scale, and they included about 63 million Medicare beneficiaries aged 65 years old or older in the United States. They looked at daily PM2.5 predictions at 1 square kilometer spatial resolution across the US from a well-validated ensemble model. Sorry. They found that a 5-unit increase in PM2.5 was associated with 1.13 times higher risk of Alzheimer's disease. So there is mounting evidence showing that air pollution exposures can be related to clinical outcomes of neurodegeneration. So you may question why or how air pollution exposures increase the risk of cognitive decline, MCI, and AD. So here is some clue from Alzheimer's disease continuum. So the natural course of AD goes forward, but the research trend goes backward. So recent studies have focused on preclinical stages. So we can look at accumulation of amyloid beta or hyperphosphorylated tau or brain cortical thinning. And these biomarkers are very important in defining Alzheimer's disease biologically. And recently in 2018, a so-called ATN framework was introduced by National Institute on Aging and Alzheimer's Association. So A represents amyloid beta, and T represents tau, and N represents neurodegeneration. And we can categorize ATN profiles using this table. And as you can see, A positive, T negative, A positive, T positive, A positive, T negative, but N positive. They are all on Alzheimer's continuum. ATN is kind of natural course of AD, as you can see in this figure. So amyloid beta, A is followed by T, and T is followed by N. And neurodegeneration results in MCI and then dementia. So all your studies have focused on clinical stages like MCI and dementia, but all your studies have looked at neurodegeneration using neuroimaging techniques. And more recently, we can look at amyloid beta and tau in blood or other using CSF. Then how to measure ATN? CSF amyloid beta and amyloid PET are used to measure aggregated amyloid beta, and CSF phosphorylated tau and tau PET can be used to measure aggregated tau or neurofibrillary tangles, and anatomical or structural MRI, FDG PET, and CSF total tau can be used to measure neurodegeneration or neural injury. And among these diagnostic tools, which may be the best tool we can easily use? I mean, it should be cheap and with good compliance. So I think we can use structural MRI to look at neurodegeneration. This is a very good tool. So there have been numerous brain MRI studies linking air pollution and neurodegeneration. So from internationally well-known US courts like WHI study, Framingham Court study, and ERIC study. And in Korea, there's the FNEP study. And in Europe, there are UK Biobank studies, Alpha study, and 1000 Brains study. In these studies, numerous brain MRI markers were used, including vascular markers such as white matter hypointensities, cortical volume, and cortical thickness. I just want to let you know about how to analyze brain MRI data. We can use 1.5 Tesla or 3 Tesla brain MRI scanners. And 3 Tesla brain MRI has higher resolution, and we can get cortical thickness values from 3T brain MRI. And the cortical thickness is more sensitive to brain structure changes compared with cortical volume. And there are 2 approaches. First one is region of interest approach. The second one is voxel or surface-based approach. In the region of interest approach, we can predefine large brain areas such as the frontal lobe, and then we get cortical thickness in the frontal lobe, and we run association analysis. And this is strengthened by facilitating clinical interpretation. And the voxel or surface-based approach does not predefine any brain areas, and it runs association analysis on each vertex or on each voxel. And we can detect small brain areas associated with exposure and visualize them. I'll show you later on. And in terms of a program, we can use PreSuffer or SBM. I'm going to introduce some neuroimaging studies on air pollution. And from WHI study, there were 2 studies by Chen and Casanova. The study population was almost the same, and they looked at PM 2.5 exposure and underwent 1.5 Tesla MRI analysis. So Chen's study used RI-based analysis, and Casanova studies used voxel-based morphometry. And they found some significant associations between PM 2.5 and some brain regions. They only looked at cortical volume. And the Alpha study is a prospective cohort study of middle-aged, cognitively unimpaired individuals. But many of them were offspring of 80 patients. So they had a higher frequency of the APOE4 allele compared to general population. And about 200 participants underwent 3T brain MRI. And they measured AD signature average cortical thickness. And they found that some significant, but it was borderline significant association between NO2 and average cortical thickness and PM10 and AD signature average cortical thickness. Last, I want to introduce the FNEP study, Environmental Pollution Induced Neurological Effect Study. This is a multi-center community-based cohort study commenced in 2014 in Korea. As you can see in this figure, the cohort covers low-risk urban area like Wonju and Pyeongchang, high-risk area including Incheon Namdong Industrial Complex, and moderate-risk area in Seoul, the capital. And we recruited 50-year-old or older adults without history of dementia, movement disorders, and stroke. Part of the participants who were enrolled between August 2014 and March 2017 were invited to undergo brain 3T MRI scans. And this project is led by Professor Chang-Soo Kim in the Department of Preventive Medicine and Yonsei University College of Medicine, and is funded by Ministry of Environment. From this EpiNAP cohort, I had done some analysis using about 1,000 adults with complete brain MRI data. In this study, air pollution data were derived from spatial temporal modeling using National Air Pollution Monitoring data. And we looked at long-term exposure levels of PM10, PM2.5, and NO2, which was estimated based on participants' residential addresses. And we conducted both region of interest-based analysis and surface-based morphometry using the FreeSurfer. In the ROI-based results, PM10 was associated with decreased cortical thickness in the frontal lobe and temporal lobe. And we also observed decreased subcortical volumes of the thalamus and pallidum, hippocampus, amygdala, and nucleus accumbens. NO2 was associated with decreased cortical thickness in the frontal, parietal, and temporal lobe, and subcortical volumes as well. And this figure shows results from surface-based morphometry. If you look at this yellow or red area, this shows cortical thinning area. And as you can see, PM10 or PM2.5 mainly affect the temporal lobe. By contrast, NO2 was associated with cortical thinning across the whole brain. So I think PM and NO2 involve different patterns of cortical thinning associated with the exposures. So this might be just, I think, the effect of PM on the temporal lobe may be attributed to the effect of ultrafine, very small particles entering via the olfactory nerve. In future epidemiological studies, we can look at not only association with MCI or dementia, but also mechanism using advanced techniques to look at preclinical stages like cortical thinning on MRI and amyloid beta and tau as well. But this, if you look at this figure shows how we can look at the mechanism of cortical thinning associated with environmental exposures. If you look at this panel A, this is a very classical pathway of ATN. So A is followed by T, and T is followed by N. But other pathways are also possible. If you look at this panel C, A and T simultaneously can affect N. And if you look at this panel F, some unknown factors can induce A and T, but independently N. So these efforts are very important in preventing dementia associated with environmental exposures because it can provide clue to when and how to intervene. If you look at this figure, amyloid vaccines have been developed and trialed. So this, just imagine, what if some environmental exposure does not involve amyloid pathway? Would this vaccine, amyloid vaccine, be effective in preventing dementia associated with the exposure? So the complexity of the mechanism behind the relationship between air pollution and neurodegenerative disease is very challenging, but I think obviously it is very worth exploring. So I've been involved in this EpiNAP study from its beginning in 2014. And so many researchers, EpiNAP researchers, have been supporting me and this study, and I'm very grateful for that. Thank you for your attention.
Thank you, Dr. Zhou, for your nice presentation and your very nice quote named EpiNAP. And your study is so novel study. Yeah. Our very recent interest is for the brain effect, cognitive function and Alzheimer, Parkinson's disease. And for this study, the MRI is a very powerful tool for the preventive measure to find some significance. So I think there are some couple of questions. Are there? Yes, Dr. Ho-Kim, please.
Yeah, I'm Ho-Kim from Seoul National University. I'm rather interested in the exposure side. Do you have any idea of the exposure period or lag effect? How long exposure would have an impact on this kind of disease or degeneration?
Thank you for the question. We are looking at a variety of environmental exposures, including particulate matter, NO2, like air pollution exposures, as well as some PAHs, hydrocarbons, and heavy metals. So we collect blood and urine, and then test for to collect heavy metal levels and pH levels. And regarding PM and NO2 exposure period, we estimated long-term exposure to PM and NO2, like 5-year cumulative concentrations of PM and NO2, or just 1-year average concentration of PM 2.5. So we wanted to look at long-term exposure to particulate matter and NO2.
Yes, and I also have a couple of comments and expect your very brief answers. Have you found some susceptible population in your court? I think you need to focus on the susceptible person, such as cardiovascular or pulmonary disease persons. Another point is, for the more preventive viewpoint, this finding of cortical thickening is how much it is related to actual cognitive function. Very brief answer, please.
Okay, thank you for the thoughtful comments and questions. And I think identifying susceptible populations is very important in environmental health research. And I have done some subgroup analysis considering chronic diseases such as hypertension and diabetes, but the result was not that promising, probably due to insufficient statistical power. But I found some significant effective modification of systemic inflammation in the relationship between air pollution, particulate matter, and this brain cortical thinning. So I found that men with high level of hs-CRP, which is a good indicator of systemic inflammation, were more likely to have cortical thinning associated with particulate exposures compared with men with low level of systemic inflammation.
Okay, thank you very much. For the time limitation, we need to move on to the next presentation. Thank you again, Dr.
Thank
Cho.
you.
And we'll have a virtual presentation from Dr. Neus Rosell. Is currently the project manager of the brain birth cohort named BISC, Barcelona Life Study Cohort. Its cohort is from the prenatal period to the childhood, adolescence, and later. So she conducted research for biochemistry and immunology in the past, and now currently she is part of Childhood and Environment Department at IS Global. It's in Barcelona. And she's very much interested in environment and children's health, and also air pollution and climate change and food system. So we'll invite Dr. Neus. Yes, thank you.
Good evening, everybody. My name is Neus Rosell, and I'm presenting on behalf of Dr. Payam Dadban from the Barcelona Institute for Global Health in Spain. And I wanted to express my gratitude, my most sincere gratitude for the invitation. I hope you're enjoying the symposium, and that unfortunately I couldn't attend fully. Therefore, I will present this talk on air pollution and brain health through a video recording and join you later for 5 minutes of discussion. So during the following minutes, I'll be covering this topic. I'll be sharing some insights about the relationship between the air pollution exposure to brain health through our knowledge based on epidemiological data produced through our study cohorts. And then present you the new cohort called BEAST that can give a frame of the envision we have for the next year to study these different ways of understand the impact of air pollution that we created some years ago with the direction of Jordi Sunyer and Dr. Payam Datban. So just to give a frame of the topic, I know this is not new to most of the audience today, but just to give a glimpse on the setting of our work, where we seek for associations between the exposure to certain environmental factors to the population health. And this needs to be understood as a complex system of determinants of health, including these factors such as genetic, sex, or age, and then the inter-individual ones that can be lifestyle, social capital, or the environment they live in. So digging in a bit more, our proposed model for the exposome includes all these exposures that the individual might be subjected through the life course, considering the personal exposome that is related to lifestyle and habits such as diet, physical activity, or smoking patterns, sleep, and external exposome that relates to all the external factors such as climate, green spaces, noise, light, or air pollution. That is the one that I'm going to cover more today. And how those are interrelated to the biological responses is also included in this model. Those are the pathways that can lead to health outcomes, being the most known or identified: the gut microbiota, gene expression, metabolomics, or epigenetics. So focusing on air pollution, which is the major public health concern to its relation to preventable deaths worldwide, as well as high levels of morbidity. It accounted for more than 8 million deaths in 2018 and is the main urban-related environmental hazard. Almost all the global population, 99%, is breathing air that exceeds the WHO guideline limits and contains high level of pollutants, with low and middle-income countries suffering from the highest exposures. And to link it to the theme of the symposium, I think it's important to bear in mind that many of the drivers of air pollution, that can be like the combustion of fossil fuels, for example, are also sources of greenhouse gas emissions. So policies to reduce air pollution, therefore, offer a win-win strategy for both climate and health. Not getting into details, but we know there's many sources of air pollution, many pollutants to consider in health. And that's, a broad perspective to bear in mind. Regarding environmental insults hallmarks, Peters and Vaccarelli provided a comprehensive framework for understanding why complex mixtures of environmental exposures induce severe health effects, even when at low concentrations. And they're capable of linking environmental exposure to chronic disease such as cancer, respiratory, cardiovascular, and metabolic diseases, and also diseases from the nervous system, which is the one that matters for us today. I don't know if this is too small for you, and maybe the organizers will share my slides with you all, so you can dig in a bit on this. But just wanted to briefly touch on this matter, that environmental exposures such as noise, heat, light, they have a direct effect. They directly activate the nervous system, and then has effects that promote stress responses in various brain regions. There's also evidence that traffic-produced nanoparticles from air pollution can reach the brain via the olfactory nerve and via systemic translocation. And furthermore, ultrafine particles that are smaller than 100 nanometers, for example, can translocate from the lung when breathing air pollution into systemic circulation and reach other organs, including the brain and the placenta. This is another model, another example of these interconnections, interrelations of these patterns that can then target certain organs such as lung, heart, or the brain, which is the one I'm talking more today. But another example of these associations can be found on the alterations of mitochondrial DNA content that has been identified as an etiological determinant in a variety of human diseases. And precisely the importance of placental mitochondrial function during in utero life on fetal brain development can have long-lasting consequences on the IQ, the intelligence quotient. And it is also important to consider that many of the environmental insults can occur simultaneously and multiplying their impact in these urban settings. Most of these insults occur at the same time, and then having these impacts added one to another can have even worse consequences in health. In terms of brain, it is also known that the brain is vulnerable, particularly vulnerable to neurotoxic chemicals throughout the life course, and that impaired development and programming of the brain then can hinder functional maturation and even trigger adult neurological diseases and neurodegeneration. Having said that, I think it's important that we consider children population as one among the most vulnerable to suffering adverse effects due to exposure to high levels of air pollution. Emerging evidence suggests that a pathway that this happens is through neuroinflammation. So from exposure, from exposure to the breakdown of the epithelial barriers, increasing the immune system and producing neuroinflammation and cell loss. So children have higher sensitivity to air pollution because of their less developed neural barriers and also other natural barriers in the lungs warding against inhaled particles, reducing the brain's capacity to protect itself against toxic particles. And also children, we have to consider they have a higher breathing rate to body size ratio, so they breathe more times than adults, and they also spend a significant amount of time outdoors, more significant than in adults. So those are things to consider when talking about development of brains. And now I would like to bridge this to a study we performed in schools. We wanted to see this air pollution that they were exposed at their schools. We could see then through a school year, how the air pollution that we were seeing in their schools, that we would measure in their schools, in yards and classrooms, how this would affect the development, the growth of the cognitive function, and in that case, we considered working memory, among other. How this was related, and in this graph, I don't know if my camera is gonna cover part of it and if you can see it clearly, but here it's seen very clear how the kids that were exposed to lower traffic pollution exposures, they had better school performance in general. So we have these big differences at the age of 7 to 9 years. Yeah, let me jump to the next one, which is like the MRIs that we conducted to more than 300 of those children that we were just measuring school performance. So MRI offers an unprecedented non-invasive access to studying in vivo mechanisms linking early life environmental exposure with structural and functional brain changes that potentially can underpin adverse neurodevelopmental outcomes. So unlike questionnaire-based assessments that we commonly use in children's environmental health research, MRI is providing an objective, highly sensitive tool that also may better identify subtle subclinical changes prior to the onset of clinically recognizable disease, which is very interesting. So in this study in schools, we didn't find any structural change at the age of 9 years from the environmental exposure and brain's anatomy. But when we did the functional MRI in resting state, we saw same changes, but in the opposite direction that we found when we compared children at different ages. So our interpretation was that the effects of air pollution were not profoundly enough at these ages to produce structural changes like anatomical anatomical changes, but are able to act in the maturation of networks and the integrity of the different networks of the brain, like a delay in age in the age maturation of the brain. So perhaps this is pointing out that air pollution exposure at those ages is something that could be reversible and not very profound. In parallel, we found interesting results in terms of green space exposure, as when we measured with satellite data the amount of vegetation in schools. We also found a difference between children that went to a, let's call it, green school and those who went to a green school. We were able to reconstruct the whole life exposure at home of these children to vegetation, since we assume that the vegetation during these 9 years didn't change. Finding then, yes, structural changes in the MRI of the children with the different vegetation exposures in early life in the prefrontal cortex. And this is something that it also was published by Dr. Payam Dadban, 2018. So these made us think that perhaps early life exposure, when the brain is developing faster, could have a more profound effect. And indeed, when we reconstructed with linear regression models the home exposures from prenatal life on these children, we found an effect of prenatal exposure to particles with the size of the corpus callosum, which is the major white matter tract in our brain. So we are relating something that happened early in life with the corpus callosum at 9 years. And as you see in the image in the right, which is from another publication from that study, we associated the home exposure during the life course to the cognition at the age of 7 to 9 years, where we saw an effect during the prenatal and early life, raising then the point that early life exposure perhaps has a more important effect, which is very much related to what we know from basic science and from other studies in animals. From animal studies on the effects of air pollution, it is clear that the major culprit is the effect on the glial cell. And we know that the microglia plays a big role on myelination. Myelination is a process that starts in the middle of the pregnancy and lasts several years, but mainly its major growth occurs during the first years of life. There are studies that confirm that in maize, that shows how the exposure of the mothers affect the corpus callosum of the new generation, but also in children, like our study or other studies from Generation R. There are also studies in humans that have shown in children how prenatal exposure to particles affect the white matter volumes, both in the New York cohort and Generation R cohort. I'm just touching this briefly. You can see in literature all this has been published, and here I put you the references. So all of this is the basis of the frame that we built to design our new cohort. Our model is that the exposures from the beginning of the pregnancy will have a greater impact. Here you see these arrows are proposed from literature, and as bigger the arrow, the stronger is the evidence, the weight of the evidence. So we do have evidence that the particles affect all the hallmarks in our bodies. We know it's going to affect the mother, and it's probably going to affect the placenta, but we don't know. We don't have the evidence on that. Although we have evidences that particles affect the hallmarks of the placental function, which then we can measure this placental function through ultrasound Doppler. So there's evidence also that there will be particle deposition in the placenta. So our hypothesis is that the placenta here is playing a big role in this model, being linked to the intrauterine growth retardation, which will be then linked to having a brain impact and the brain development of the fetus being affected. So those are the basis of this BEAST cohort, the Barcelona Life Study cohort that we started 3 to 4 years ago in the city, the metropolitan area of Barcelona in Spain. When we started the follow-up of these children very early in the pregnancy. So it's the beginning of the pregnancy, all the process of the pregnancy, and then the first years of life that we would follow this development of the brains. The important characteristics is that we perform a very sophisticated measurements of the environment of the mother with multiple assessments, but also that we obtained very important imaging. We did a Doppler, we did echocardiography, neurosonography, and also 27 days of life of the babies, we would conduct an MRI. So I don't want to be very go very deep on this, just like to give you a broad picture of our design of the cohort. We would have this personal exposure, and also at home with these different air pollution compounds assessments, as well as other factors that may affect the course of the pregnancy and also the development of the kid. That would be physical activity, sleep, light, or also the geolocalization. We had some commuting routes analysis for understanding the environment of the mom. And also at home, we would measure noise and temperature. This is a sample size around 1,080 women that participated on this. So regarding the brain, that is our focus, the transvaginal neurosonographies were conducted at the 32 weeks of pregnancy. We had a very highly trained obstetricians, as this is a very subjective measure. So we had to really make sure that it was being done properly. And then in these, we could have good imaging of the corpus callosum inside the belly, and having information about each dimension, as well as the sulci, the fissures, and lateral ventricle. So we do have now this data. We are still in process of data cleaning because of COVID-19. We had a lot of delays, but this is something we will expect to release very soon. And then, as I mentioned, we conducted all these MRIs at 27 days of life. Because we found it was the best balance between having some mature images of the brain development while avoiding all the Mason artifacts. We didn't want to anesthetize the kids. They were very, very, very small. And we used natural sleep after breastfeeding. So this was also delayed, and we had complications because of COVID. So it was more difficult to develop. We could only obtain 134 images, from which only the 41% are complete. And among them, we had some incidental findings that we had to take care of. So we're now in the process of analyzing all these images. Also, this is complex because it has to be done manually, the definition of the structures. But yeah, we are working very hard on that. Regarding the outcomes that we're going to produce as neonatal imaging, we will check for volumes of intracranial and subarachnoidal space, cortical and deep gray matter, as well as white matter, lateral ventricles and cerebellum, as well as tractography metrics of preselected sensory motor pathways and specific white matter tracks. But yeah, and just to finish, the idea is to follow these kids and to evaluate their neurodevelopment through different follow-ups at the age of 6 months, 12 months, 18 and 24, where we are performing different tests regarding language, regarding behavior or communication, such as Bailey's test, MacArthur, BRIEF, or EEG. So we are now on this process, and we expect this to be finished in the couple of next years. But yeah, the idea is that we can start seeing these associations between the exposure that the mothers had during the pregnancy and this new generation of kids that were born in the cohort. So that's it from my side. I hope that was interesting, and I hope we can have a nice discussion. I'm gonna connect for 5 minutes of live discussion, and please don't hesitate to contact me or Dr. Payam in order to discuss or to comment on any of this. Thank you very much for your attention, and looking forward to talk with you. Thank you.
Hello, Nils. Hello, good to see you. And
Hi,
thank you
good
for your
evening.
nice presentation. We really like your cohort and recent study results led by Dr. Jordi Sonia and published in very prominent journals and impressed for the children's neurodevelopment. And we'll take a question from the floor first. Is there a question? Yes.
Hi, Ms. Roselle. Thanks for the nice presentation. I kind of get question because of the current study that I'm doing in here, because I'm currently studying the neurodegeneration in association with air pollutant on the aging people, on the people who are like over 50 years old with their aging, with the neural degeneration, like air pollutant associated with neurodegeneration. And in your cohort, you have like recruited people before like of mother who, and then once they give the birth, you also recruit them to such as like follow-up study. And I was kind of able to get some insight that the brain structure changes before their birth until they die, I mean, with their aging as well. But in your study, I didn't really hear like what are the average concentration of particulate matter or nitrogen dioxide level. So would you mind to share the concentration in your area or province with us?
Sure. Thank you. Thank you very much for your question. I hope you can hear me well. So it's very interesting. Our studies don't focus on neurodegeneration because we are focused on early life and pregnancy mainly to see like the brain's development. In terms of results, I can share. Right now, we're still analyzing all the filters that contain these nitrogen dioxide compositions. We know most of the mothers exceeded the limits recommended by the WHO guidelines in terms of like exposure to air pollution in their surrounding areas where they live. But we haven't yet got all the results from the lab, so I'm sorry I can't share about this.
All right, all right, it's totally fine. Thank you.
It's still very premature. I hope in the next years we're going to be publishing on this.
Sure.
Okay, thank you. Is there any others? Yes, from Professor Cho. Yes.
Hello, I'm Jerim at Yonsei University, and thank you for accepting the invitation despite time pressure. Thank you so much. And I was curious about environmental exposures you are investigating. And do you plan to include any other environmental exposures such as endocrine disruptors? That's the question. Yeah.
Yes. Yeah, thank you again for the nice question. Endocrine disruptors are something we're also checking. We collected urine samples during the whole pregnancy. So we had 2 bunches from the first and third trimester of the pregnancies where we were collecting urines from the mothers during 7 days. We collect morning and night urines. And this way we can see also if there's an impact and any association between the air pollution that were exposed, the black carbon particles as well, PM 2.5 to the urine compounds, as well as others related to stress that we did with hair samples, for example. So we're trying also to see cortisol levels on hair and nails as well during the pregnancy and afterwards. So we are collecting as well children's nails. And yeah, I think that's it for this matter. But yeah, we're definitely very interested on this because it's, as I mentioned in the model, it's one of the pathways until we understand the effect in brain of the exposure to air pollutants.
Thank you. Thank you. Due to the time limitation, we have to reserve our further discussion next time. Keep in contact. Thank you again, Dr. Nels Rossell. Bye-bye.
Thanks for the invitation.
Okay, we'll move on to the next speaker from China. Professor Xiaoli Duan is currently a professor and deputy dean at School of Energy and Environmental Engineering in the University of Science and Technology of Beijing. Before the university, She was a leading researcher in Chinese Research Academy of Environmental Sciences under the Ministry of Environment and Ecology of China. When she was there, she led the first nationwide environmental exposure-related human activity patterns survey and developed the first Chinese exposure factor handbook for adults and children. It's a great job. And she's now the president of the Asian chapter of International Society of Exposure Science and acting role in Chinese Society of Environmental Science. She also is one of the member of guideline developmental group on WHO guideline for indoor air quality. She was awarded the National Science and Technology Progress Award in 2008. Please, Xiaoli, Professor Xiaoli.
Good afternoon, Professor Xin. Good afternoon, everybody. It's my great honor to be invited to this joint international symposium hosted by the Korean Academy of Science and Technology and National Academy of Medicine of Korea. I feel so sorry that I could not be there to communicate with you in person because the pandemic situation. Sincerely hope that it could be better so that we could have more opportunities to meet face to face. I'm from University of Science and Technology, Beijing. First of all, please allow me to introduce my institute a little bit. The university is located on the North 4th Ring Road in Beijing, which is not far away from the Summer Olympic Park and Winter Olympic Park. This is a logo of our center, Center for Environmental Exposure and Health Research. HIRE here stands for Health Improvement by Reducing Exposure, which is our goal. And H stands for elderly person. I looked at children. R look like pregnant women. So these are susceptible population that we care about in our center. And E stands for general population and also stands for environment and the first capital city of exposure. So that means we care about not only sensitive population, but also general group. In this slide, the blue, green, and brown leaves stands for air, water, soil, and food, which are multi-medium exposure that we are focusing on. Hire, it sounds like be hired. That's our wish that after graduation, our PhD and master students can be hired. But also, hire sounds like higher pursuit, higher platform. We have a wish that our students graduated from our center can have higher requirements, can contribute higher to the construction of our country and to the society. So that's our will. Welcome to visit Beijing. Once you have a chance, please remember to contact me. I will show you around our university and the Olympic Park and other side of the Beijing. Thank you. My topic today is interaction of air pollution and physical activity on human health. We all know that more than 90% of people worldwide live in areas exceeding the World Health Organization guideline for healthy air. The guideline 10, which was the old standard. So if with the new standard 5, this figure could be higher. And more than half life in areas that do not even meet WHO's interim target 1, the least stringent air quality standard. Air pollution is the fifth leading risk factor for mortality worldwide, which contributed to almost 5 million deaths globally. In China, about 45 decreased in national PM2.5 exposure during the last decade. The improved air quality led to 308,000 and 16,000 avoided long and short-term exposure-related deaths. However, compared to the World Health Organization AQG standard, the levels in Chinese air quality is still quite high. This is the air quality standard in China compared with WHO AQG. As we can see that for PM2.5 value in AQS in China, the first level is 15, the second level is 35, which is consistent with WHO interim target 1, 35, but still far away from AQG level, the new standard 5 microgram per cubic meter, which was released in last year. And at the same time, people love to exercise outdoor. In some days like this, blue skies, which is good, but also in some days with heavy pollution, occasionally, the physical activity may increase their doses of exposure. This table shows the short-term inhalation rates. As we can see that it's increased dramatically with the higher intensity. Of course, we all know that physical activity is also having the health benefits, such as the long-term physical activity is good for our brain health, heart health, can prevent cancer, and it's good for our weight and bone stress, etc. And even short-term exercise is good for our sleep, and it could release the anxiety, and it's good for our blood pressure. And the global burden of disease showed that the elimination of physical inactivity increased the life expectancy of the world's population by about 0.68 years. Well, as we can see that, on one hand, the physical exercise is good. We have the benefits by exercise. However, if the air pollution is higher, the deeper or the more intensive exercise may increase the inhaled dose, which may cause a risk to our health. So this is like a dilemma. What could we do? Well, what is the interaction between the air pollution and the physical activity? What can we do? Or on which threshold could we do exercise, or could we not do the exercise? That is the scientific question we are proposing. Well, let's see the long-term effect study first. This is a study carried out by Southern California University. They found out that the incidence of new diagnosed asthma is associated with heavy exercise in communities with higher concentrations of ozone. Many other studies in other countries or regions, such as in European, Danish, China, and other places, has carried out the research on the long-term exposure to air pollution and physical activities. But the results so far on the long-term exposure are not very consistent. As we can see that some people or some study found out that there's no interaction between physical activity and PM2.5 exposure. But the other studies found that there was a significant interaction between PM2.5 and the physical activity volume in association with incident hypertension. Well, we found out, we also have had two studies on the long-term exposure to ambient 2.5 and physical activity. One study is from Chinese national nationwide representative sample, which showed that physical activity had beneficial effects on obesity-related choice at all levels of long-term PM2.5 exposure, but association were attenuated, accompanying with the increase in PM2.5 concentration. This is one of our study. And the other study is based on the China Health and Retirement Longitudinal Study, which found that the threshold was approximately 77 microgram per cubic meter for the vigorous intensity physical activity group. And the group of walking, the threshold was approximately 81 microgram per cubic meter, which means that for the respiratory health, by doing different kind of exercises, the threshold of PM2.5 is not the same, which is based on those studies. So to sum it up on the long-term exposure study, that studies on interaction between physical activity and long-term air pollution exposure still remain inconsistent. Studies in some low exposure settings suggested that there is no interaction, but others said yes, so which needs further study. And the second, evidence on the links between air pollution and physical activity is needed in highly polluted regions, such as in the big picture that I showed on the first page with the red color, like in East Asia areas and some Africa areas. So there, the last one is there is limited evidence on the sensitive populations, such as the person with pre-existing chronic diseases, etc. Okay, then let's see about the short-term effect study. So this is a study in Belgium, this beautiful city. They like to test whether they could or whether they need to encourage people to do more cycling along a very busy traffic road. So they had this study by this kind of subclinical study. On one group, they asked people to cycle in the real road, and the other group, they asked them to stay in a clean room. So they found out that traffic-related exposure to particles during exercise caused a small increase in the distribution of inflammatory blood cells in healthy subjects, even in healthy subjects. So we know that at this this study, actually the PM2.5 level and the air pollution level is not that high, but they still find these results of exercise in heavy pollutants could increase this kind of inflammatory blood cells. And of other studies in other places, Canada, Belgium, Spain, UK, Poland, etc., or had this either panel or crossover studies on the short-term exposure effects of air pollution and physical activity. So this one in Barcelona, this study found like that they found out the evidence of interaction for physical activity and PM10 and PM coarse particles could increasing the blood pressure. And another study found also in Barcelona found out that physical activity could reduce the negative impact of the traffic-related air pollution on heart rate variability and this high type size. But on the contrary, in other places or in other studies, they found no evidence of heart rate variability response to physical activity. The black carbon exposure or interaction was observed. And in highly polluted areas in Beijing, the study found out that the frequent exercise might protect against PM 2.5 associated arterial stiffness, but could accelerate airway inflammation. So this is a study, also a study in Beijing, a panel study. So because of the inconsistent results and because most of the studies are in very low PM 2.5 level areas, and because not one study not has been using the real exposure dose, so we carried out this study funded by National Science Foundation. We were trying to find out whether the increasingly real exposure dose of the air pollutants caused by the heavy exercise could increase or could have some interactions on human health. So we conducted this real-world crossover study among 74 healthy adults. So each adult participant were divided into two groups. So for one group, they could sit there for 2 hours without exercise. The other group, they had about 15 minutes intermittent moderate physical exercise exposure scenarios lasts for 2 hours, totally 2 hours. So about a 2 to 3 weeks washout period, they change. So the group of the exercise, they changed to the sit group, and the other one changed to be the exercise group. And we monitored their heart rate and also monitored their health effects and air pollution in this study. So one question is that how could we measure their real inhalation rate? So before we have this study, we conducted another study, which is called cardiopulmonary exercise test in the lab. The purpose of that study is to establish the heart rate and ventilation, the relationship, so that in that case, after establishing this relationship, so in the real world crossover study, we just need to monitor their heart rate so that we could get their ventilation and inhalation rate. In that case, we can calculate their actual exposure dose. So that's the unique part of our study. So this one is the study on heart rate and ventilation relationship study. So this is a laboratory cardiopulmonary exercise test. Each participant wore a chest strap with integrated electronic device for continuous measurement of heart rate, and also a facial mask for the simultaneous measurement of ventilation for the entire test. They were asked to do exercise with increasing load of the intensity, so that we could get their in ventilation in different exercise status. So their heart rate and the ventilation relationship was established. We found out that the heart rate could be a very good predictor for the ventilation, and we established the novel equation for the relationship in each person, so that we have their real relationship. In that case, we could do this crossover study and use this relationship to derive their real inhalation rate. So these are some measurement equipment for air pollutants and their health outcomes. We also collected their blood sample, urine samples to monitor the biomarkers. So the results find out that the exercise group showed less decrease in FEV1 divided FVC, and also FEF 75 than the non-exercise group. Also, the findings suggested that the same exposure status active physical activity group had less reduction in respiratory responses than those who were inactive. So more results are coming on these biomarkers and health effects. So this is an ongoing project. Okay, to sum up of the short-term exposure study. So the research mainly concentrates in high-income countries, and the current results are also not very consistent. The short-term health effect of physical activity may be weaker or even non-existent at higher levels of air pollution. So studies on the combined short-term health effects of air pollution and physical activity in real-world situation is not that much. It's really needed. So finally, that's the in results of our long-term and short-term interaction study and also other studies. We find out that the long-term PM2.5 exposure may attenuate the benefits of physical activity on health, but these results are not that consistent in some ways, although some threshold has been derived. So further cohort studies and further more concrete studies are needed. And for the short-term interaction studies, we also need to conduct further studies to clarify the potential mechanisms to really understand the interaction between the physical activity and air pollution. And more studies were also needed to focus on other pollutants such as ozones, etc. Because now, even in Beijing and even in some other parts of China, with the decreasing concentration of PM2.5, it seems increasing of ozone, especially in summer season. So thank you very much. That's basically my presentation. Last but not least, I would like to take this opportunity to welcome you to join ISES Asia chapter. The picture here showed a very important conference in 2010, the ISES and ISEE conference. The chairman of that conference was the president is Professor Dongchun Xin. This is really a milestone because that is the first time ISES and ISEE International Conference was held in Asia areas, which is the first time ISES changed its name. The previous name is ISEA assessment and then changed to ISES, which was the first time that ISES was ahead of ISEE. So that is one of the best, and which is the best and the conference that I have had. I really enjoyed my time. I enjoyed this conference in Seoul. And about here, this is ISES Asia AC Asia chapter. Asia chapter was funded also by Professor Xin in 2008. He was the first president of ISES AC, and I am the current one. Thank you very much, Professor Xin, for your all-along help. Without your help, nothing could happen. All this ISES, the exposure science development in Asia areas, regions. Thank you very much. Hope more people could join us to join hands to promote the exposure science in Asia regions. Thank you very much.
Hello, thank you, Shaoli.
Hello.
Yes, for your
Hello,
nice.
Professor Xin.
Yeah, thank you for your nice presentation, reviewing all the past or existing result studies in the world, and also your study results as well. And those are very much informative and helpful for us, and we can
Thank you.
utilize that result in our practical life, depending on our environmental situation and also our health conditions. And I will take a question from the floor first. Is there any question? Yes, Professor Cho. Yes, from Yonsei University.
So I'm Jerim at Yonsei University, and thank you for your presentation. And it is very impressive, and it was very informative to researchers, will be to policymakers, and particularly the study published in Stoughton by Guo. And it was very, it suggested a threshold of PM 2.5, outdoor PM 2.5, and reversing the beneficial effect of physical activity on the health effect. And I think I was reading on some articles about the role of physical activity in the association between air pollution exposures and brain health outcomes, such as depression and some brain MRI markers. And the first one was published in Journal of Affective Disorder, and it showed some beneficial effect of physical activity. But the study published in Neurology did not exhibit the same findings. And so we can say that there are mixed findings. So I just wonder if you have any plan to include neurological outcomes or brain health outcomes in your study.
뭐 연결이 끊겼나? Yes. Okay, Professor Shaoli, I think there is now the technical difficulties for the transmission of voice and screen. So Okay, we have to move on to next presentation. Anyway, thank you. If you can hear now, Shaoli, for your nice presentation, and we'll meet again in the near future. Okay, and we'll move on to the last presentation of the today, and we are waiting so long for her presentation, and I think it's very, very interesting and very newer proposition for the disease and chemical pollution in our environment. So, as you can see, the program of today, the last part is my closing remark, but I think it's a buffer time for the delay of the presentation. So you can use enough time for until I think 6:30.
Oh, okay.
Okay, please.
Yeah.
And I should introduce for the recording, Professor Ducky Lee is a professor in the Department of Preventive Medicine, School of Medicine, Gyeongbuk National University in Daegu, South Korea. Her research area is health effects of low-dose chemical mixtures. Very, very distinct area, especially persistent organic pollutants. She has published more than 200 research articles in peer-reviewed international journals, and she served as associate editor of Environment International. It's a very prominent journal, and an editorial member of Environmental Research, Current Environmental Health Reports, and Journal of Epidemiology and Community Health. Thank you. Please, Dr. Lee.
Thank you for introduction. Anyway, as the last speaker, I will finish my talk as soon as possible. Today, my talk is a missing link of obesity-related diseases, lipophilic chemical mixtures as mitochondrial toxins. Is the contents of my talk. Let me start with puzzling findings on obesity. As you know, obesity is a public health crisis worldwide. Obesity is increasing everywhere, men and women, children and adults. Also, the obesity is it is well known that obesity increases the risk of many diseases. However, there is a phenomenon known as obesity paradox. Actually, the risk of developing diseases are increasing among obese persons. However, like this, however, the risk of death after developing diseases is higher in lean persons. So, obesity paradox is commonly observed in patients with many diseases. Like this. So this pattern looks definitely like a paradox. At present, the most popular explanation on survival benefit among obese patients is bias. It's all kinds of bias can explain this pattern. The main idea is the more adiposity cannot be beneficial in any situation. However, obesity paradox is still an ongoing debate. Some researchers strongly insist obesity paradox does exist. I am the one of them. If you search PubMed with the keyword of obesity paradox, you can find out over 3,000 articles, and the numbers of articles keep increasing. The next is public puzzling findings on weight loss. There are two types of weight loss. The first one is unintentional, spontaneous weight loss. Second is intentional weight loss. Generally, spontaneous weight loss is regarded as a sign of poor prognosis. So consistently, spontaneous weight loss is related with the increased risk of all-cause mortality. However, intentional weight loss is commonly considered good, so highly recommended for overweight or obese persons. I will show some puzzling findings from Look Ahead study. Look Ahead study is a multi-center randomized controlled trial. The study participants were over 5,000 overweight or obese patients with type 2 diabetes. These persons were randomized into two groups. First one is an intervention group. They did the weight loss by diet and exercise. The control group did usual diabetes sport and education program. They were followed 10 years and the primary outcome was cardiovascular disease event. Actually, there were remarkable improvement of non-cardiovascular risk factors in the weight loss group. However, there was no difference in cardiovascular event in two groups. Can you understand how can no difference in cardiovascular disease event is possible, even though because there were remarkable improvement of a known risk factor in weight loss group? It's very strange. So as you expect, the result from Look Ahead study caused a huge debate. There are another strange results on cognitive function. In Look Ahead study, cognitive function was measured as an early mark of dementia. The weight loss group showed an improvement of many non-risk factors for dementia. However, again, there was no difference in cognitive function between two groups. More surprisingly, there were some subgroups which showed worse cognition in the weight loss group. So it looks quite strange. So the perplexed findings from Look Ahead study suggest that there should be unknown factor X which can trade off the benefits of intentional weight loss. So what can be the unknown factor X? Up to now, researchers' basic premise on adipose tissue is adipose tissue a pure organ. However, the truth is all adipose tissue is widely contaminated with various environmental pollutants. The typical chemicals stored in adipose tissue are persistent organic pollutant, POPs. I will skip the characteristics of POPs because Professor Zhang already mentioned them. Also, various less lipophilic chemicals are also detected in human adipose tissue. So we can say that adipose tissue should be considered as a dump place for poorly metabolized various chemicals in living organisms. There is a compelling evidence that lipophilic chemicals can affect diverse systems at low dose: endocrine system, metabolic system, nervous system, immune system. Low dose means lower than the current safe levels. Here, the toxicokinetics of lipophilic chemicals. When lipophilic chemicals enter our body, they are primarily stored in adipose tissue, and then they are slowly released to circulation through lipolysis. Once they release to circulation, they can more easily reach to critical organs. The amount of lipophilic chemicals reaching to critical organs are very important for human health. So, from the viewpoint of other critical organs, storing lipophilic chemicals in adipose tissue can be protective, actually. From now, I will call various lipophilic chemicals as POPs for simplicity. Then there are two situations. PAPs are more released to circulation from adipose tissue. First one is obesity. Obesity is the situation with the increased basal lipolysis, so they lead to the increase of release of PAPs from adipose tissue to circulation. The second situation is weight loss. During weight loss, there is the shrinkage of a storage site. It leads to the release of PAPs from adipose tissue to circulation. From the viewpoint of adipose tissue, it can be seen as an opposite situation, because one situation is obesity, the other is weight loss. It's a complete opposite situation. However, from the viewpoint of PAPs, they are similar situation, because both of them lead to the increase of PAPs in circulation. So the interrelationship between adipose tissue and PAPs can explain obesity paradox. Usually people think that more adiposity is always harmful. However, from the viewpoint of lipophilic chemicals like PAPs, having more adipose tissue can be beneficial, because it can protect other critical organs as a primary storage organ. So this role of adipose tissue can be more important among patients who are already suffering from the disturbance of homeostasis. If you are interested in this idea, you can read this review article. Also, PAPs can explain the puzzling findings from Look Ahead study. We published 2 articles on this issue. First one is the intensive weight loss increased the release of PAPs from adipose tissue to circulation. When they reach to critical organs, they can be a long-term harms, even though the weight loss showed the short-term benefits. So it can explain why there was no difference in cardiovascular events between 2 groups. It is similar with the cognition. Actually, brain is the most repeated rich organ. So the lipophilic chemicals like PAPs can more easily go to the brain compared to other organs. From now, I will go further. Lipophilic chemical mixtures and obesity-related diseases. Until now, I told lipophilic chemical mixtures stored in adipose tissue can explain puzzling findings on obesity or weight loss, like obesity paradox, possible harms of intentional weight loss. However, from now, I will say well-known relationships between obesity and obesity-related diseases can also be explained by PAPs. My point is, obesity alone cannot explain obesity-related diseases. Actually, as I told you, the obesity with the increased basal lipolysis increased the release of PAPs to circulation. Type 2 diabetes is the most important obesity-related disease, and I have spent most of my research career to investigate the relationship among PAPs, obesity, and type 2 diabetes. You can refer to these 2 review articles on this issue. But importantly, in the real world, we can separate obesity and PAPs. These 2 factors are both sides of the same coin. So we have to always consider these 2 factors together. Let me give an explanation with the example of metabolic syndrome. Metabolic syndrome is a very well-known obesity-related disease. Under the current paradigm, there are well-known molecular mechanisms. The first one is a pro-inflammatory status of adipose tissue, increased fatty acid in circulation, and ectopy fat accumulation. There is no mention of PAPs. However, PAPs are involved in all these mechanisms. PAPs can induce a pro-inflammatory change of adipose tissue. The animal study showed the mice was treated with PAPs contaminated farmed salmon. It caused macrophage infiltration in adipose tissue with a high-fat diet. The inflammatory cytokines also increased. Importantly, similar pattern was observed with a normal Western diet. So PAPs can induce pro-inflammatory change of adipose tissue regardless of obesity status. Also, increased fatty acid in circulation and ectophic fat accumulation are also occur together with the PAPs. During the lipolysis, both PAPs and the fatty acid are released to circulation. Also, the PAPs are reached to critical organs, especially the places with the ectophic fat accumulation. Low dose PAPs reaching to critical organs can contribute the development of chronic inflammation because it can act as a mitochondrial toxins. At present, researchers on obesity do not consider PAPs. However, all obesity-related diseases should be considered the result of interaction between obesity and PAPs. Persistent organic pollutant in adipose tissue should be considered all obesity research. So we need to have a new perspective on obesogens. There are chemicals known obesogens, which is obesity-inducing chemicals. However, obesity-inducing chemical induce the increasing number of adipocytes, hyperplasia, that we need to have a different viewpoint. Especially the exposed to obesogens during critical period of development, it usually increases hyperplasia. Obesogens can contribute the expansion of a healthy adipose tissue, actually. At a given obesity level, there are two types of obesity, hyperplasia-dominant obesity and hypertrophy-dominant obesity. Actually, hyperplasia-dominant is not harmful. It's beneficial, actually. The problem is a hypertrophy-dominant obesity. However, obesogens can contribute to this kind of the healthy obesity. The next is lipophilic chemical mixtures as mitochondrial toxins. Mitochondrial function is a key in human health. It related to the many chronic diseases as well as infectious diseases as well, like COVID, SARS-CoV-2. High-dose PAPs are well-known mitochondrial toxins. It is very well-known from early toxicological studies. However, the question should be low-dose PAPs, similar to current exposure levels, can act as mitochondrial toxins. My answer is yes. I will show the result from our own study. We presented the evidence from human study and in vitro study. Human study were performed among over 300 adults, and we measured the PAPs and the oxygen consumption rate of platelet and PBMC. This kind of markers can be used as an index of mitochondrial function. Decreased oxygen consumption rate, OCR, means the impaired oxidative phosphorylation in electron transport system in mitochondria. There were strong inverse associations between PAPs and the basal OCR. This figure shows a summary of the human study. The upper panel is the platelet OCR, lower panel is the PBMC OCR. PAPs was a strong inverse association with the OCR of a platelet or PBMC. However, obesity was not related to mitochondrial function, actually. In vitro study used 3 cell models, human platelet, human PBMC, and Jurkat T cells. We treated 3 chemicals, PCB mixture, beta-hexachlorocyclohexanes, and DDT. And we treated concentration of 0.1 picomole to 100 nanomole. It's very similar to very low human current human exposure levels. Also, we mimicked the chronic exposure. We treated the chemicals up to 7 days. The results from the in vitro studies are somewhat complicated because of non-linearity. Also, they differ depending on cell models, doses, and durations of treatment. However, the bottom line was the chronic treatment to low-dose PAPs decreased the basal OCR, similar to findings from human study. Actually, mitochondria is a target of many, many environmental chemicals. The target for tobacco smoking and even air pollution. Actually, tobacco smoke and air pollution are other typical examples of the chemical mixtures. So we need to have a more broad viewpoint. Mitochondrial function is crucially related to chronic inflammation. There is a vicious cycle between these two mechanisms. At present, most researchers do not consider many environmental pollutants can act mitochondrial toxins at low dose. Conclusion. I think lipophilic chemical mixtures is a missing link of obesity-related diseases and puzzling findings on obesity or weight loss. Also, these mixtures act as mitochondrial toxins and are related to the chronic inflammation-related diseases. I hope that you feel the pieces of puzzle are put together with these lipophilic chemical mixtures. The problem is this issue cannot be solved by traditional approaches on environmental pollutants, such as strict regulation or avoidance of exposure sources. This kind of approaches cannot work. So I suggested new approaches. In this approach, I suggested in high dose range, we can use the traditional method. However, in low dose range, we should use a human-focused approach. The key points of human-focused approaches are, first, the current chemical-based reductionist approaches cannot protect humans from possible harms of low-dose chemical mixtures. The most important exposure source is already inside us and not outside us, adipose tissue. So all living organisms have an ability to manage xenobiotics, even the lipophilic ones. Also, all living organisms have an innate repair and recovery system at cellular levels. So we need to activate these two systems through intermittent and mild mitochondrial stress responses, which is sometimes called mitohormesis. We can use a diverse lifestyle for this purpose. If you are interested in this idea, please read these two articles. Evolutionary adapted hormesis inducing stressors can be a practical solution to mitigate the harmful effects of chronic exposure to low-dose chemical mixtures. Mitochondrial toxins and healthy lifestyle meet at the crossroad of hormesis. My collaborators, thank you for your attention.
Thank you, Professor Lee, for your very interesting presentation. My first question is, as we mentioned, if weight loss increases the release of microbial toxins from adipose tissue to circulation, it is very, very worrisome to try to weight loss or by exercise or something. So what is your practical recommendation in our situation?
Yeah, it's a very, very, very important question. When we consider both the obesity and the PAPs together, the issue is really complicated. However, I have a couple of practical suggestions for obese persons and persons who want to lose weight. First, they need to manage the mitochondrial mitochondrial toxins in circulation, everyday life. So as I told you before, the diverse lifestyle, healthy lifestyle consisting of the proper diet and the exercise can be used for that purpose. It's the first recommendation. The second recommendation is steady and slow weight loss is very important because the release of chemicals from adipose tissue to circulation is proportional the magnitude of weight loss. So the slow and steady weight loss is very important. The third recommendation is the weight fluctuation should be avoided because the weight fluctuation leads to the redistribution of these chemicals from adipose tissue to critical organs. So we can expect the long-term harmful effects. So these three factors are very important for this kind, those persons, I think.
Very critical recommendation. So if we follow your recommendation, our body, you know, we are very unfortunate. We are already contaminated with by the environmental pollutants, various kinds, lot of. And then if we follow your recommendation, our body system, such as hormesis, hormetic effect, will balancing and will optimizing our, not optimizing, will minimizing our health effects and harmful effect from that chemical. Is it right?
Yeah. Until now, the researchers in the field of environmental pollutants are mostly focused on the pollutant outside us. So they always are trying to minimize lower the exposure levels and something like that is a very important things for them. However, when we look at when we think about the pollutants in our body, so we need to find out solution from our living system rather than outside. So your comment is perfect, correct.
Okay, Professor Yang, please.
I'm Yang from Seoul National. I'm actually a surgeon, but today when I listen to your lecture, I admire why we need preventive medicine. A different view how obesity, this is actually a problem, especially advanced nowadays, many countries are suffering. And we always focused on how to reduce this some intake by making stomach small, but from your point today, your lecture looks like this obesity is really not a matter of simple. I mean, so all those some chemicals making cells full of lipid, then it's not functioning. So maybe not easy to control. So how about you might have some speculation or some future expectation how to control obesity people? I mean, it's a difficult question, but different approach maybe we need.
Yeah. Well, I feel my answer might be similar to the answer to your question. It's not unclear for me what is the difference of between your question and your question.
His question was for
I think we need enough time for discussion, but time limitation. But I like Professor Yang's question because Professor Yang is an oncology professor, and as I remember, you, Dr. Lee, mentioned long years ago that some mild obese, not very much obese, mild obese is not that bad for the cancer mortality.
Yeah.
Is it still effective? So in that context, Dr. Yang asked you, in that case, if it is the true, how we can recommend obese people to maintain their health?
Yeah.
Yeah.
If obesity persons have some metabolic problems, it means that they it means the pollutant stored in adipose tissue is an unstable status. So they need to lose their body weight actually. Yeah. However, in that case, the recommendations I already told is very important. However, there are persons with a healthy adipose tissue. So sometimes we call them the healthy obese. In that case, I think the weight, weight loss might not be good for them. They just keep their healthy adipose tissue as have their own role to store this pollutant into the adipose tissue. Actually, once they are released to circulation, they can easily go to the brain. So yeah, in the brain, it can cause some neurodegenerative diseases. Yeah, a lot of problems. So yeah, depending on healthy obese, unhealthy obese, yeah, we can choose the different way of the control body weight.
Okay, so we very much need to, for the thinking, discussing, and for the research to reveal or to go near the fact of what you mentioned today. So you are the first runner in this field, and you suggest a new proposition in this. I believe it will be successful. So I ask you to keep on this track in the future. Yeah, keep this course and provide us for the concept and for the concrete interconnection between chemical contaminants and obesity and various diseases we are worrying about.
Thank you.
Thank you. And any other comments? We need further study. Yes, yes. Thank you very much,
Yeah,
Professor Choi. And we are lucky today, even though we are a very small number here, but we are with leaders in our medical field, Professor Choi and Professor Yang, and others in this room. So if they agree with our pollution combatants, yeah, for us, Dr. Professor Yoon Seok Jang over there, we are very happy, and we have now our colleagues to solve our environmental health issues with our disease. So this is my closing remark. Yeah. And thank you, Dr. Lee, and thank you all the speakers and participants and leaders in our medical field today. Thank you very much. I close today's conference.